hit a button. Oh, hello there. It's stream number 292. And I think again today I'm going to work on Advent of Code. I kind of went through over the weekend and did a bunch of them. On Friday I had done through day 4. And then over the weekend I did 5 to 10. And so I'm on 11 right now. Hey there, Nui. So I was having so much fun doing this that let's see if I can catch up to the current day. I actually don't even remember which day we're on now. Let me look this up. Advent of Code. Okay, we're on day 6. They're up to day 16 now. So I have 6 that I can do today until the next one unlocks. Schedule still 10, 12 to 16, 12. Oh yeah, sorry about that. Let me give you a point. Let me fix that really quick. I always forget something. Shoot, how do I do that? Probably need to go to my extensions, right? And then my extensions. Advance to the next week. Okay, let me put my schedule in. So I'm streaming today, obviously. Whoa. That didn't do what I thought. Okay. I'll probably end up streaming Wednesday too. Actually, let me leave it off just in case. Yes. Actually, I'll probably do Wednesday instead of Thursday. Let's just say that's gonna be the schedule. Save. Alright, so now it's up to date. Yeah, sorry about that. Kind of neglected to update my schedule. You know me, I always forget something. You know, getting old, memory fading. Okay, okay, I forgot a couple other things, right? So I don't have a link to this. So let me get that. So it's just like these habits just don't form for me for some reason. I don't know why. Maybe it's just because there's so many things that I do to set up the stream. Hey there, TS Jost. Hey there, Manir. I'm still setting things up today, but yeah, I had so much fun doing the Advent of Code that I'm going to continue and see if I can catch up. All right, today's copy link, tiny URL, copy to clipboard, make sure the link works, and it worked. So go in there and paste, and then let's put it in Discord too. Stream plan. I'll say, had so much fun with Advent of Code that I made it to day 11. I made it through day 10 over the weekend. And I'll be streaming it again today, starting with day 11. There we go. All right. I got Discord updated. I haven't been doing Twitter because I don't know why. I need to rethink what I do with Twitter. Maybe I need to find a Twitter guru to teach me the fine art of using Twitter. Anyway, I updated Discord, updated my plan. I have the link correct. Oh, I didn't put this into the bot. Let's see what the today says. All right, so let's update that. And let me put the link, replace the link in there. There we go. I am addicted to Advent of Code. Hey there, Dries Jans. I hope to catch up. Maybe not today though, but we'll see. Yeah, previous years too. How many years does it go back to? Is there a way to finding that out? 2015? Do I just have to type in 2015 to find it? Yeah, 2014 doesn't exist, so there you go. Oh, look at all these puzzles we could do. Anyway, oh, click events. Okay. Got it. Thank you, TS Joss. Hey there, Rami. Wowee. How are you today? All right, so as you can see, I did 5, 6, 7, 8, 9, and 10 after Friday's stream. A lot of it was on Friday, but then I think I also did a few on... Actually, I can't remember. But I was up late doing these. Was she dedicated enough to actually follow through on the event? But you can, Rami. You can do like what I did and just catch up. The only problem that you'll have is you won't be getting a whole lot of stats. See, for mine, my personal stats, they're abysmal, right? So I was the 87,172nd person to do day one. But you can see I'm getting, either I'm catching up or fewer people are doing the later days. Or they're like me and they're starting late. So you too could start now and catch up. So I'm averaging about 45 minutes per day, and I think I'm slow in comparison with others. So, you know, if you had like a day, you could probably catch up. Do you have buttons to give points, or do you type super fast? I use Yata, which Hideo made, and it lets you set up shortcuts, or I can click here. I'll actually well, playing with scissors says I shouldn't show it, but what I'll do is I'll click it and I'll do a screenshot, and then you can see the screenshot. How do I show a screenshot? I guess I'll do Paint. Was this MS Paint? There we go. So I have there's this little thumb buttons, and you click it, and I have these shortcuts. So I can give a point, or I can say hey, or I can do a shout out or a wowee, which I do for Rami. And yeah, it's very convenient. You're buying, I'm selling, whatever I'm selling. Yeah, so yeah, shout out to Hideo, who does not stream, but who makes custom Twitch chat client that I use. Anyway, let's look to see what day 11 is about. Okay, on the way to Jupiter, you're pulled over by the space police. Attention, unmarked spacecraft. You are in violation of space law. All spacecraft must have a clearly visible registration identifier. You have 24 hours to comply or be sent to space jail. Oh no. I guess there's a link to space jail. What's space jail? Oh, all quotes from Purple. Okay. Funny. Not wanting to be sent to space jail, you radio back to the elves on Earth for help, although it takes almost 3 hours for the reply signal to reach you. So that means that we've already lost 6 hours, right? So it's really 18 hours to comply. They send instructions on how to power up the emergency hull painting robot. They even provide a small encode program that will cause it to paint your ship appropriately. There's just one problem. You don't have an emergency hull painting robot. Oh, by the way, I should, I'm going to use a stopwatch to time how long it takes me. I'm going to start it now. You need to build a new emergency hull painting robot. It needs to move around on the grid of spare panels on the side of your ship, detect the color of its current panel, and paint its current panel black or white. All the panels are currently black. Encode program will serve as the brain of the robot. The program uses input instructions to access the robot's camera. 0 if the robot is over a black panel, or 1 if it's over a white panel. So we give input to the program based off of our current state of our panels, right? Then the program will output 2 values. First, it'll output a value indicating the color to paint the panel. 0 black, 1 white. And that's consistent with the state, right? 0 was always black, 1 is white. Okay. Second, it will output a value indicating the direction the robot should turn. 0 to turn left, 1 to turn right. After the robot turns, it should always move forward exactly 1 panel. The robot starts facing up. The robot will continue running for a while like this and will halt when it is finished drawing. Do not restart the computer inside the robot during this process. For example, suppose the robot's about to start drawing black panels as dots, white panels as hashtags, and the robot pointing the direction it is facing, left, up, right, down. The initial state looks like that. and the panel under the robot is not visible because we're on top of it, is also black. So any input instructions at this point should be provided 0 because everything is black. So suppose the robot eventually outputs 1 and then left. After taking these instructions, it would be white, turn left, and move. That makes sense. And you should provide 0 because it's on top of black. And then if it outputs black, it does a 0. And then turn left, turns left, and move down. So that's paint still black again. And then 1 0 1 0 mean it is white left, white left. So white, turn left, white, turn left. There we go. Robot's back where it started, but because it's now on a white panel, the instructions should be provided 1 because we're on top of white. Got it. So then it's black right, white left, white left. Yeah, that makes sense. Before you deploy the robot, you should probably have an estimate of the area it will cover. You'll need to know the number of panels it paints at least once, regardless of color. In the example above, the robot painted 6 panels at least once. See, let me think about this. 1, 2, 3, 4, 5, 6, 7. But it crossed a panel once. That's 6, right? It painted the starting panel twice, right? It's only counted once. Also, it never painted the panel it ended on, right? Build a new emergency hull painting robot and run the encode program on it. How many panels does it paint at least once? Okay. I guess we go until it halts, right? Hey there, Pro Sam. How are you doing? Hold on a second. All right. Sorry about that. Your head hurts? Your head hurts? This is day 11. So when they talk about int code program, that's from a previous day's puzzle. It's essentially a little machine language that they invented for the challenges. And there's like 5 or 6 different instructions in that machine language. And it can do basic input and output. And in the later puzzles, they added loops and conditions. Basically all the things that a real computer would have. You missed that part, yeah. So they give us the machine language to run on the machine that we've been building, and that machine language, is the program that our virtual machine basically is going to run, and then we're going to feed that virtual machine input, and the input is going to be what is the current state of where the robot is over, and then the virtual machine's output tells us what to paint and then which direction to turn. You think encode is every other problem? It's like 4 or 5 of them so far. So, like the last one I did was actually kind of fun. It wasn't encode, it was destroying asteroids. First it was detecting and then destroying asteroids. So it was basically ray casting. So you'd have to go to every one of these hashtags and ray cast in a big circle to see how many other asteroids you could see, and if you saw one but there's one behind it, the one behind it you wouldn't see. So the part 1 is to find the place where you can detect the most, and part 2 is actually using a rotating laser destroy the asteroids and then figure out which one is the 200th asteroid destroyed. So that one didn't use the int code. Let's see, what about 9? 9 used the int code computer. 8 did not. 8 was like an image decoder. It's like every other one is using the int. So 7 is using the int code computer. 6 was not. So it's like every other one. Every other day was using the int code computer. So it makes sense because 10 was not the int code computer based puzzle. It was the asteroid one. That means 11 will use it. That makes sense. So I'll probably want to start by copying day 9 and not 11. So I'm going to take day 9 2 and call it 11.1. And then add to the build system, and then go into this make file and make this 11.1, and then start to build. Hey there, Endurn. How are you doing? And hey there, Userman. Do you love the recurring encode personally? Yeah, I love it too, because we're building a virtual machine, so you get to learn a lot about how computers work at their core. So here's what the state-of-the-art Raimu int code computer looks like. It's now an object, which I called machine, and it has, I'm bad at names, so the machine language memory duo, because they're now combined. The memory of the machine is also holds its instructions. I call it the numbers, and then you can feed it input, and it produces output. So the way that works is you fill in the memory, and then you call run, and then based on pause, which is the instruction pointer, it's loading like which operation it should do. And most computers work this way. The what is it called? I can't remember the name of it, but the part of the CPU that's loading the instructions and interpreting them is going to load an opcode, usually, and then based off of that opcode, it says, so what should I do? Add, multiply, input, output, and these are the basic conditionals. So jump or not. What jump if something is true, jump if something is false. And then there's here the comparisons. And these would be probably combined with the jumps. So compare two things if one is less than another, or compare two things if one is equal to another. And then they added a little bit more complexity. They added two new ways to load data into the machine. The first way was to load from an absolute memory position, and the second way was to load just an immediate value like a constant. And this is the third way, which is to load from memory, but using not an absolute position, but a position relative to a base which can be moved. And opcode 9 adjusts that base. And then the 99, which is basically that we're done. Hey there, Romania. How are you doing? JNE and JEQ, yeah, exactly. You wrote mine in you wrote yours in Python? You had a dict that maps opcode to function. I guess I could do the same too. Switch is like the poor man's dictionary. I could make each one of these a function, a method of my machine, basically, and then have a table that maps from opcode to function. But I wasn't really interested in making it the most optimized. In fact, on Friday when I was working on problems 1 through 4, I got distracted too much, I think, trying to optimize it, and I could have done it faster just by going with the brute force solution all the time. Yeah, now I have a queue of inputs and outputs because that was required on, I think, day 7. In day 7, it has you put a chain of 5 int code computers, and so like computer A, the output of computer A is the input to computer B. And so it made sense to me that if we're going to run it as a chain, that the inputs make it easy to put in, to make the outputs of one become the inputs of another. So I just made them both vectors. So when you run a machine, it gives you a vector of outputs. And then before you run it, you can set its input as a similar vector. Your state struct contains an action, and the user will run a step function and inspect the action to do stuff like input, output, or resisting. Interesting. Yeah, is that OCD? To just try to, like, say, oh, this is not fast enough, I need to make it faster. It got annoying to have all the modes next to each other? Yeah, this is sort of one of my faults, I think, is that, where was run again? I tend to make functions that are too long, and you see this run function? It's way too long. And the main culprit is that huge switch statement. I've been working over the last year to try to get better at that. So an appropriate refactoring here would be, like Userman said, to take all the fragments of the machine that are different depending on the opcode, and put them in separate functions, and just have a lookup table or dictionary. But are we going to refactor Advent of Code challenges? No, we're just gonna do them. I need to see if I need to change my machine in any way. I don't think so. I don't think we need to change the machine in any way. We're just going to change how it works with its input and output, right? So we're going to introduce panel state, and we're going to tie that state to the input and output of the machine, right? Just YOLO it. Yoko might be better. Thank you for the follow. I didn't see who that was before it managed. Want to see the unit test? There's no unit tests. We're doing this raw. You only code once. Oh, Yoko. Yeah, there you go. Although that in-code computer, since it's being reused, every other day's puzzles are using it. I at least made them refactoring stuff of putting it into an object. I think before day 7 or something like that, it wasn't an object, and it was, and like it should have been from day 1. It has its own state. It has an instruction pointer. It has its input. It has state whether or not it's halted, and then this relative when they added relative base and then had multiple machines, that was the final straw for me. I'm like, I need multiple machines, therefore I should just make a temp at least, and if not, just a full-blown object. So that's what I did. All right. So I need to have state. Let me pull in the input puzzle. Oh, wow. All right, that's our int code program. So that replaces the program that we had from the previous example. So yeah, this is the int code program. It's almost impossible to understand unless you worked on the Advent code. Basically, you start at the beginning, and this is an opcode with some additional modifiers. So that 3 that we saw earlier... Hold on, I lost my place. I should have pinned that and pinned that. So the 3 opcode is input. So the first thing that this program does is input and place its input into memory location 8. And then it does the opcode 5 with that 8. And 5 is jump if true. So it's comparing to see if you input a 0 or 1, which makes sense because what this robot is doing with that 0 or 1 is determining if it's painted white or black, right? Remember this sort of code from D2? Yeah, this int code computer is every other day of Advent code this year has been using and refining this int code computer, Andorn. So it's not coding only once, it's coding 4 or 5 times now, this int code computer. You're still on day 3? Okay, am I giving away spoilers then? That you'll eventually be adding more opcodes like jumps and comparisons and relative addressing. I think after day 3 or 4, you start to realize this is going to be a reoccurring theme, this int code computer, and it's going to eventually have everything that a real computer would have. Day 3 is impossible? I had a hard time on day 2. Day 2 took me a long time because I was trying to solve day 2, part 2, without using brute force, and I couldn't do it. Yeah, day 2, part 2, I finally gave up and just took a brute force approach. Right, day 2, part 2 was you had to find out what 2 numbers were between 0 and 99, and I couldn't do that without at least brute forcing one of them. So I said, like, well, loop through all 0 to 99 of one of the numbers and try to figure out if you can get a second number from the first number. And it works fast enough, but it took me a long time because it took me a while to realize I'm not smart enough to find the solution without brute forcing it. So 5 took you the longest? Okay. I had an average time doing 5. The quickest one I did was 8. That was a really fun one. I don't want to say what it is because it'll give away the fun for Andorn, but I thought number 8 was really cool. I got through it really quickly. Hey there, Mr. Love Pickle. How are you doing? So, I forgot to update the current task, right? I'm not setting up the stream anymore. We're working on puzzle 11-part 1 of Advent code. All right. So, did they give me a map? So, it gives us a clue here. Before you deploy your robot, you should probably have an estimate of the area it will cover. So I'm thinking unlike these samples, which just assume it's 5 by 5, I think we shouldn't have any kind of assumption. We should just make it an open-ended data structure. And I had a type, like, I'm going to reuse position, right? Looks like we used it in day 10. So just a simple structure that represents a coordinate in space. Let's pull that over from day 10 and plop it here. And then let's have like a map from position to a Boolean, and if it's not in the map, we haven't touched it yet. And if it's in the map, it'll say what color it is. Then all we need to do at the end is just count the number of things in the map, and that'll be our answer. One neat thing you learned from Advent was that most grid problems can be done using dictionary or set with positions as keys. Yeah, so that's what I've been doing, Userman. I have a lot of sets and dictionaries in my solutions. So, for example, the asteroid one, which one was that? Was that 9? No, 10. I have sets of positions for asteroids that we've already hit. And where did I have another one? I had a map where I determined the angle for every target. So yeah, maps and sets. The map is the C++ equivalent of an ordered dictionary in Python. There's also unordered map if you just want a hash table. And yeah, it's a reoccurring theme. It's really good at pointing out alternative solutions. Yeah, like after one of us comes up with our solution, we can look at other people's solutions and say, hey, that person had a different way of approaching it. So like, for example, I think eventually I want to go back and for day 2, part 2, where I had to brute force solution, I'd like to find, in fact, I think I did write down that iGrok or someone else had solved that. Oh, okay. iGrok had a better one for 3 part 1, but for number 2 part 2, he probably also has a solution. So I eventually at least want to look at 2 part 2, if not his 3 part 1, which he claims is better than mine, just to compare and see, you know, what I kind of missed, what I could have done better. All right, so this is the same thing in the beginning, right? We're loading our machine. And this input, though, where's this input coming from? Oh, this is reading from the command line, so we don't want to do that. So here's where it stops, right? So let's say construct machine. So that's this part. And then in general, we're going to construct the panels to be painted, and then run the machine, providing as input the current state. We should say construct the panels to be painted along with the robot state. Did you say day 2 part 2, which you wanted to compare? Yeah, my day 2 part 2 was brute force. It took me over an hour. I wasn't happy with it because up until that point I didn't need a brute force solution. Yeah, okay, so let me compare it with yours eventually. That would be awesome. I feel like I'm pretty dumb sometimes. And I'm sure I'm going to look at your solution and iGrok's and I'm like, oh yeah, I should have thought of that. Unless you too use brute force, and then I'll be like, ah, I'm not alone. Other people had to brute force it. Okay, so run the machine, providing as input the current state of the panel, and taking the output as directives to the robot, right? Of course you use brute force. There's got to be some people who didn't, though. See, I did the same thing, Endorn. But I'm sure one of you guys did it without brute forcing it. I have a hard time with Yada grabbing chat lines that are just links, but I managed to do it. So I would like to compare my solution to day number 2 part 2 with those of others. These, and I'm sure I'll just grab the iGrox one too. Oh, come on. Don't use the brute force. I want to you guys are better than me. There's got to be a way to do it without brute force. Some kind of mathematical five-head big brain solution. There's got to be. Okay. We don't need... No, I do need that. That's how we run the machine. And I want to do this in a loop until it halts, right? Okay, so this is not needed anymore. Actually, we can do that in a loop. Right? And I think it said it's only going to ask for one input every time, right? Right. So the only input is the color of the panel it's on, right? Let's see. Right. It's instructions to access the robot's camera. So every input is what is the current color of the panel it's on. So I think for the panels, like I was saying before, I'm going to use a map from position to Boolean. And the absence of something in there means it isn't painted. So we would say it's black if it's not in this map. Map is not in my includes, though. Wondering how you could get a solution without brute force? Yeah, exactly. I couldn't figure it out. It was too hard for me. Panels, and then we need to record where the robot is, right? Robot position. And then we need to know which direction they're facing. I think I'm going to do it in terms of another position. Let's make some constant positions that represent orientations. So static position orientations. Actually, let's do a little bit more than this. Let's do static struct orientations for, or orientations equals this. And I want to do a little bit, a combination of two things. I want to have position delta, and then I want to have like what it means to turn left and right. So let's use indices. So size t turn left, size t turn right. And then these orientations will be I guess I need to give the struct a name, right? Back in 5 minutes? Okay. You're gonna go figure it out? By analyzing and reversing the entering the encode. That's what I did. Well, mine is a combination of brute force and analyzing and reverse engineering the encode. I ended up analyzing it and then wrote a solution that runs the encode computer backwards. And but for the beginning point, I had to make a guess. I couldn't figure out how to not guess. So I guessed on the output and then worked it back to find what the input was. Oh, you're moving. You're not solving 2-2 without brute force. I see. Do I have a constructor for position? I don't. Let's make one because those are kind of convenient. Int x, int y, x, x, y, y. There we go. Now we have a nice constructor. And I should probably... I can never remember. I guess we should have a default constructor, which does nothing. What compiler am I using? I am using Visual Studio Community 2017, building for 64-bit Intel. And hey there, Jay. I don't know how to pronounce your name, so I'm just going to say Jay. Hope that's okay with you. Yeah, we are using Visual Studio Community 2017 to try to solve the advent of code challenges. I'm using Visual Studio Code, which is geared to use Visual Studio Community 2017. Yeah, I'm using Visual Studio Code, but I'm using the compiler from Visual Studio Community. Yeah. It's a little confusing because Visual Studio is in both names, right? All right, so I want to have in position, for orientation 1, let's pick, I guess, up because that's the default of the robot. So up would be, actually, can I do it this way? So 0, -1 for X and Y, and then to turn left would mean to go point to the, so if this is left, let's keep it simple. So left, no, I mean, sorry, not left, up. So let's go clockwise. So that's right, down, left. So turning left would be to go to index 3. Turning right would be to go to 1. If we're pointing right, then turning left would be to go to up, and right would be 2, right? So this is down, pointing, turning left would be going to right. Yeah, so it's just walking. Like that, right? Thank you for those follows. Okay, let me get the coordinates correct. So right is 1, 0, right? And down would be 0, 1, and then left would be -1, 0. You see where I'm going with this? So that I can just change the robot's position by adding. And I'll even make a nice little operator for that, because why not, right? We will say void operator plus, actually, if it's doing it this way, let's just do plus equals for now. The const position other. And we should return ourselves, right? Like that. So x plus equals other x, y plus equals other y, return this. So now I can add positions to each other. All right, back. Hi, Anakin Luke. How are you today? Highs. All right, so the robot's position, and we'll have the robot's orientation as well, right? The orientation we can use just an index. So robot orientation is 0, which means up. I'll put, just for convenience, the indices here. There we go. TBD Gamer, thank you for that host. Yeah, we're working on Advent of Code today, because I got really hooked in on it Friday, and I'm kind of trying to catch up here. I'm on day 11. If you were to go to Advent of Code, you'd see that the latest is 16, so I don't know if I can catch up today. I'll probably get to 13 or 14, optimistically, and maybe I'll catch up tomorrow. And thank you for the raid, too. Both a host and a raid. Welcome. How was your stream? That's okay. No problem, TBD Gamer. How was your stream? You want me to do day 14? I don't know if I'll get that far today, because optimistically, I think I'll get 3 done. Maybe we'll see 14. But yeah, we're working on day 16 of Advent of Code. Oh, no, I'm not. I'm working on day 11 of Code. The robot painting one, if you've done this one before. Building on the int code compiler that is the subject of every other day so far. My AOC command is out of date. It is, yeah, you are correct. Let me give you a point for that. Let's update that. Edit com AOC. I decided on day 13 to try to have the code. So far, it's made it to day 11. There we go. Fixed it. So yeah, if you haven't started Advent of Code, you could catch up too. It has been taking me only about, I don't know, about 45 minutes to an hour for each day. So you can't, I don't expect anyone to be able to catch up in one day unless you're really, really good, which you might be. But you could at least catch up in like 2 or 3 days, and there are still plenty of days left. There are 25 days total. So you could probably catch up and compete on the very last day if you started now. And even if you took your time. All right. So I want to do this in a loop, right? Until it halts. And then we're going to count the number of panels we actually painted. So while not machine halted. We're going to run this. And we're going to, at the end, we're going to say printf some number of is it tiles? Panels. Panels were painted. And that's going to be panel size. If your laptop battery wasn't dead, you'd probably have a go, but don't care about competition. Yeah, I'm not really competing either. The real competition in Advent of Code is to get points, and the way you get points is to be one of the first 100 to solve the problem. Or another, I guess, a not so heroic competition, like the normal part of the competition would be to just look at your own stats and just try to get as low a number as you can, and maybe you compare with other people. So you can see I started so late that there's no way I'm really competing. I'm just kind of having fun. Unless I were to catch up, and then maybe there's some opportunity for competition, right? But I'm not really the competitive type. You can create private leaderboards. Yeah, so we have a private leaderboard amongst some of the fine folks from Adam13531 stream. And because it's private, I'm not going to show it. But if you're a member of his community, there was discussion there. I think Endorn set it up. So I'm on Endorn's leaderboard. For what it's worth. Oh, I didn't see some of the people chatting. Hold on, I missed some folks. How come I don't see their chat? My stream helper tells me that they said hi, but I don't see where they said hi. Okay, Resubaka, it was at half an hour ago. I'm sorry about that. There's the hello. So here's my hello back, Resubaka. Sorry that it took me so long to reply. And then Razor, I didn't see your chat, did I? I'm so bad sometimes about detecting new people who are in the chat. Oh, why do most C++ constructors use initializers rather than just setting this equals this? It's just a newfangled syntax. We're talking about this. This is just kind of cool for us old-time C++ people. So we're like, oh, let's just do that. So yeah, you're right. Alternatively, I could have done this, where I just use the initializers, right? x0. And then maybe that's more comfortable to for people who have been using C++ a long time. I tend to think that this is better because, whoops. This is better because it's you can see in its place if you forgot to haven't had an initializer. Whereas if there's some distance between these two, let's say you have a whole bunch of other lines here and you're sitting here. Let's say I said, oh yeah, I know I have an X. Let's say I forgot that I had a Y. I wouldn't see it by looking there. I'd have to be looking nearby and say, oh, there's a Y. I forgot a Y here. Whereas if you do it this other way, it's very obvious if you missed an initializer because it's just missing. And you're like, what should Y default to? That's why I've been preferring it. So anyway, hi, Razor. And then Ancient Coder, I didn't acknowledge you. Where was your chat? At 10:40. Hold on. There it is. It was part of the raid. There we go. And Jacomus, hello there. Technically, it's faster too. It also shows you what the default values are for the object as well as while you're looking at the header file. Yeah, so that's another potential difference that might apply to you. If you have the definition of your constructor in a different file, like if this was a header file, then this way you're providing a default at the moment of declaration. Whereas if you did it in here, it's at the moment of definition, which is different. So there are a few places where you might want to move the default assignment into the default constructor and then defer it to the definition of the constructor. And one reason would be if you can't define this because this type is opaque. I mean, int is obviously not opaque. It's very transparent, right? But if it's an opaque type, you might not be able to assign it to anything until you get to the actual definition in the CPP file. So that might be one reason why you would not use this syntax, but instead put it into the initializer list. Is that in the copy constructor? Or what are we talking about? Oh, this dot x equals x. That's just a convention. So, like x here might be ambiguous, so some people might prefer to do that. And I think in JavaScript you do have to say this dot because otherwise it won't bind it to the actual class object in certain contexts. I'm not very good with this in JavaScript though. I mean, they're all. I think with a modern C++ compiler, it'll figure out what you meant either way, and it'll end up being the same machine language. All right, let's get down to this. So while machine is not halted, we're going to run the machine, but we need to provide some initial input, right? So the input is going to be what color is underneath the robot. So let's clear the previous machine input. Actually, no, I don't need to clear it. We can just push back what the color is. So it depends on if the robot's position is painted or not, right? So we would say const auto panels entry is panels find robot position. If I guess here we'll just put it in the pushback, right? So let's make it easier to read. So we'll say color, and then if it's actually pointing to something, so if that is not equal to panels end, then we can overwrite that color with panels entry second. 1, 0, right? And let's make it even more clear. White, black. I could replace the bool with an enum. I don't know. Or an int, it doesn't really matter. Maybe I should just do an int. That'd be easier, right? Then I don't need to do this thing, I can just say that. But this is important. That means if it's not painted yet, the default is black. Thank you for the follow there. You can't assign a value to a member variable in a class body before C++ 11. Yeah, so it's recently. Relatively speaking, it's recent. Although to call C++ 11 recent is sort of funny because we're almost at 2020 now. All right, so I don't need to do this. I just push back the color, right? And then we're going to run the output. And in the output, we should expect that there are two things, right? What to paint and how to turn. So I guess we could have a check here. If output.size is not equal to 2, we can do robot did not provide correct output. There's no other things to print. Return exit failure. But assuming it has two outputs, the output 0 is the color, so we should do panels robot position equals output 0. And then which way to turn will be the output 1. So we're going to take robot orientation equals orientations robot orientation dot oh, it's one or the other, isn't it? So it depends. So it's output 1 0 was turn left, 1 was turn right, right? So let's just keep it simple. If it's 0, then it's turn left. Otherwise, it's turn right. And I'm skipping a lot of error checking, right? So if it's not 0 or a 1, it's just always going to turn right. And that's fine. I don't care. I'm not going to care to bother to check that. So once it turns, it always moves forward, right? So that's easy. We just do robot position plus equals orientations, robot orientation delta. Done. And let's go ahead and print this. Print. Robot is now at something by something, right? And that's robot position X, robot position Y. So just run it and see if it works. Okay, it didn't build. Because of this line here. Oh, right, this should go to an int, right? There we go. Hey there, Rally Monkey. I think the robot's orientation should be nobody's business but the robots. Good one, C17R. I think you get a point for that. All right. Combinations of const static reference and pointer could drive you crazy. Yeah, it could. And hey there, Huang. Also, I forgot to wave to C17R. Hi. C17R is like one of the pioneers in at least the private leaderboard that I'm on. And like he's almost in the top 100. I think, what did you get, like 150 or something in the yesterday's? Beastcam is, oh, actually he jumped up there. I had it off because he wasn't up there, but he must have jumped back up there when I wasn't looking. Here he is. Looks like it got knocked a little bit. Let me fix that. Hold on a second. That's good enough, right? Yeah, he must have gone up there when I wasn't looking. That's right, I have a beast cam now. Leg, did you see my leg while I was adjusting the camera? It come from the coding, stay for the beast cam. Oh yeah, do you guys, I had some sad news about that cat over there. He lost one of his 4 canine teeth. Or what do you call it if it's on a cat? This canine is dog, right? He lost one of his teeth. It kind of got broken and had taken to the vet. And fortunately, they were able to extract it without too much hassle. And he's back to normal. Eating just fine. Feline teeth? Yeah, maybe. So now he has 3. He is the kitty with 3 big teeth. Yeah, poor kitty. He's getting old. He's like 16 years old. So he's a Himalayan cat. I guess when they're pretty long lived, but they kind of have a few health problems, and one of them is bad teeth. That's what the vet told me. Anyway, this is building now. I can run this, right? Where is my command line? I don't have it running. Well, that would be a problem. Let's run the command line. Advent of code, build 2019 11.1. We need to copy from the source code the example input and then run it. Huh. Does it just take a long time to run? So maybe just output to out? Either that or it has a bug. It does look like it's outputting the correct instructions, though. Okay, it actually had an answer. Build. Do I want to just be bold and just submit this answer? Or do I want to try it on the example first? Because here's my answer. I don't know if it's correct. Looks like a bug. So right, it runs and it needs input right away. So then we provided... Oh no, we provided an input, right? So it stopped when it got that first input and provided that output. And then we moved... Yeah, 1 means to turn... Oh, did we turn in the wrong direction? No, 0 is left. So it painted white and then turned left and then moved. Yeah, I think it's moving in the correct direction. It's going in a circle, right? It moved left and then down and then right and then down again because it turned right again. Looks correct? Not even tempted. Just submit for science. Okay. The worst is that I lose a minute, which would probably take me that long to look for bugs anyway. Let's see if I'm right. Yep, right on the first try. The first 4 puzzles, I kept getting it wrong, and so I kind of got it stuck in my head that I would get the wrong answer the first time every time. All right, so let's take the last. I'm just stealing the commit comment from the last commit and just saying 11.1. So that was easy. Stop the timer. It took 46 minutes because I was doing a lot of talking and socializing in chat, I think. But I'll accept it that it took longer. So 0.47, I'll round up. And then we're looking at the next puzzle, part 2. You're not sure what it's trying to paint, but it's definitely not a registration identifier. The space police are getting impatient. Checking your external ship cameras again, you notice a white panel marked emergency hull painting robot starting panel. The rest of the panels are still black, but it looks like the robot was expected to start on a white panel, not a black one. Based on the Space Lost Space brochure, the space police attached to one of your windows, a valid registration identifier is always 8 capital letters. After starting the robot on a single white panel instead, what registration identifier does it paint on your hull? Oh, thank you, TS Jost. Okay, I kind of expected it was going to do this. It's going to be like, show us what it's painting, right? And the difference, because the program hasn't changed, is the difference we have to start on a white panel. Does that mean we have to go out there and paint it ourselves? After the starting the robot on a single white panel instead. Okay, so let's take 11.1 from not the build directory, but from the source. Call it 11.2. Go here, make a new subdirectory 2, and here make it 2 and 2, and then build. Be a Bob Ross. Get out there and paint, Tom Sawyer. Yeah, how do we get that first tile to start out white? All right. So the panels to be painted, so we just say panels 0, 0 equals 1. Start with a white panel, single white panel. And then we're going to run the machine as before. We have to do that. Oh, wait a minute, no, we don't do that. We don't mark that it's been painted by the robot. We just say it starts out as, so let's put that down here. Because the robot's always going to overwrite that with something, right? So it just starts out as white. It's going to either paint black or white. It's going to fill something in. So I don't need to seed this with anything. Happy little accidents, yeah. Kitty is alive and well, and he's licking his foot or something. Yeah, this is C++. Read the second paragraph. Are you going to say I'm going to screw up if I don't read the second paragraph? You mean this paragraph? I'm looking for something that I missed based on what TDS Joss said, but I don't think I'm missing anything. You notice a white panel. Okay. But what happened to the paint from part 1? Maybe it was on the other side of the spaceship. Yeah, hey there, Toulouse. I did puzzles 5 through 10 Friday evening while I was watching Ski Dog, actually. Oh, I didn't mean to give you a point. I just meant to wave. You're sorry, I gotta take that point away. Or should I just wait until you correct me on something? How much of a difference is there between C, C++, and C Sharp? Between C++ and C Sharp, there aren't as many differences. C# won't have any of these pound includes because C# doesn't have a preprocessor that does code insertion like this. But C# will have concepts like structures and methods. The names will be slightly different. I think you can't have a struct with methods. Maybe you can. Struct and class means something slightly different in C#. It's whether it's a value type or a reference type. And in C++, it's they're mostly the same except for the default. Oh, thank you for that resub, Toulouse. 6 months? That's like half a year or something. Hey, you got a new badge. Look at that. It's all nice and golden. Yeah, so there are similar constructs with different meanings slightly between C++ and C#, but it looks kind of the same. Between C and C++, stuff like this you just won't see in C. Operator overloading or references, I don't think. I think that's a C++ only thing. In C, everything is just functions and pointers. It's a lot more basic. C++ basically adds more syntax to C. Not exactly 100% true, but it's a good enough approximation. So if you were to learn all three of them, I would suggest first learning C#, and then go back and learn C. And then once you learn C, then pick up C++, and you'll be like, oh, C++ is just C with some of the things from C# added to it. And it'd be more or less correct, just not temporally. You're in the changelog of Yada. Yes, Enduran has achieved fame and fortune, maybe. Any book or resource on learning HTTP WebSocket and all? I'm sure other people in chat have resources for that. I just looked up the RFCs for it. Yeah, MDN is a good one. MDN. Developer.mozilla.org. Learn web development. There you go. They also have a really good reference manual. So you can search for like console or something and you'll find what console is that you can do a log. So, and then you can look at all the other methods of console, like error. This is how you print error messages in JavaScript. So JavaScript, CSS, and HTML covered pretty well with MDN. What is everyone's opinion of COBOL? It's still used in banks, as far as I know. But I wouldn't use it for anything else at this point. Okay, we painted the initial tile, and we're no longer interested in how many were painted, although I guess we could still print it. I don't really want to print this output anymore. I don't think we need it. I think it was just cluttering the output. Should we say where the robot is? Why not? So at the end, we want to actually see what it looks like. And so I did this in one of the other puzzles. I'm going to steal from there. Was it 8-2? Yes. Exactly this. Why write new code when you can copy paste it, right? So display what panels were painted. Actually, let's just display the panels in space. In space. Copy pasta, that's right. Hadn't realized how old it was until recently. What are some of the newer languages? C# is relatively new. Swift is very new. So Swift is what Apple is using to replace Objective-C, which is those. So those two languages are one or the other or both. You'd really need to know them if you want to work on either Mac or iOS or something like that. So Swift is pretty new. So Kotlin is also pretty new, and that's what Google wants you to use now instead of Java for Android apps. I would say Kotlin and Swift are two of the newer languages. 345 is a typo. Pained instead of painted? We can't paint them. Thank you. Let's find where all the places we did that and replace it with painted. Yay. Thank you very much, CloudHawk. You got a useless internet point. A bunch of people came in. Let me wave to you. Hey there, Canis. And CloudHawk, who I just gave a point to. How are you doing? And next, Mello, who asked about the book or resource. And then Moose. I didn't see your chat. Oh, it was you were snuck it in there. I didn't see it. All right. So the problem here is that we don't know how large it is in any dimension. I think what I'm going to do is collect that while we're painting. So we'll collect information about min x, max x, min y, and thank you for that follow, by the way, max y. And thank you, food product streams. Although this isn't a food product stream, welcome. Let's see. I want algorithm, right? Because I'm going to basically get the position painted right here, and the robot position at this point, and update it. So min x is standard min x, and robot position x. And then max x is the maximum of max x and robot position x. And you can probably guess what I'm going to do for the y's, right? Y, y, and y. So now with min and max x and y, we know the dimensions. So const auto height is max y minus min y. Const auto width is max x minus min x, right? And we can turn those into size t's, or I can just do ints here. Okay. So before in puzzle 8, it was either transparent, black, or white. So there's no more transparent, is there? And there's no more layer squashing. Right? So instead, we're going to get our pixel by looking at what was painted. So we can explicitly set it here, right? So we're going to find panel entry, const auto panel entry is panels find, and then the position we're looking for, which is min x plus x, min y plus y. Your daughter's going nuts over my kitty on the cam. Look, kitty! What's the use for decoding an image? It was solving puzzle number 8. I loved puzzle 8 because it was have your, what was it? Take your input and squash it down. It's basically doing image processing and alpha blending, and then show it on output, and then you read the letters like a dot matrix. Speak like Yoda. Speak like Yoda, I do. Speak like Yoda, I can. My kids love it when I do that, by the way. All right, so we get our panel entry. It might not be in there, right? So, like I did before, I'm going to do it again here. Oh, wait a minute. This is a bug. It'll make all unpainted tiles white. So let's go back to what I had before. Panels 0, 0 equal, or actually, you know what we should do? We should start the robot. I should just do it this way. Start the robot. Wherever the robot starts, make it white. There we go. Thank you for that follow. Now do the Emperor. Emperor is harder. I have to like get into character. It was I who allowed the Alliance to know the location of the shield generator. It is quite safe from your pitiful band. All right, so this comment actually goes here. And then this code I want to reuse down here, don't I? So that should be panels entry. And then so the output just depends on the color. So actually let's just do it this way. Static const char paints equals, and then for 0 I guess a dot for black, just like they have in their example, a hashtag for white. And then we can just say const auto pixel is paints color. And technically we want to use a size t, but it doesn't really matter. And then that should be output, not pixel. There we go. I know, what do you guys think about my Yoda and Emperor impressions? Now do Dumbledore saying, "You shall not..." That's the wrong character, T.S. Joss. It's Gandalf, not Dumbledore. You shall not pass! Something like that, right? But with more gravel. That one's harder to do. Now do Emperor doing an impression of Dumbledore with Yoda... No! It's not that kind of stream. Okay, let's just try this and see what we get. Oh, I got something. I think we chopped the bottom off. Oh, did I not add one? I should add one to here. There we go. My cat is in the way? In the way? Of what? Yeah, that would sound wrong. I use that word sometimes when I joke around, and people don't take it the right way, so I've stopped saying that word. Hey there, Who Man Bean. How are you doing? We're solving Evan a code challenges. It looks like I just solved it, right? EGBHLEUE. So I just need to type that in and I win, right? What do I win? I win the next puzzle, I guess. EGBHLEUE. Submit. I win. Yay. Okay, I didn't run my... totally forgot my timer. So I'm going to look and see what was the time of the last commit. Because I committed right after I fixed it, right? It was at 10:57, so that was 17 minutes. 17 and a half. So let's say it took me 18 minutes for that one. 11-2, 18 minutes. Yay, we passed. We're done with day 11. Let's check it in. It's not that I'm on fire. It's that a lot of these puzzles, the second part, like puzzle 9-2 only took me 4 minutes because it was basically take the 9-1 and tweak it just so slightly. I think 8-2 is similar. 6-2 is similar. 4-2 is very similar. Part 2's, some of them are just really easy because it's just take what you did for the previous one and just tweak it slightly. That's what we did, right? And this was a typo. Fix typo. Actually, before I do this, let me grab that. Oh, commit. Now we're going to say add solution for 11-2. Commit. And push. Cactus on fire? Yeah, could be. You clipped it. Did that sound okay? I guess I'll have to listen to myself and compare it to the actual movie clip. Day 11 or 12. Is this going to be is this where I kind of rage quit? Is that what you're suggesting? C's 17R? All right. Day 12. And let me start the timer. Okay, the space near Jupiter is not a very safe place. You need to be careful of a big distracting red spot, extreme radiation, and a whole lot of moons swirling around. You decide to start tracking the 4 largest moons, Io, Europa, Ganymede, and Callisto. After a brief scan, you calculate the position of each moon, your puzzle input. You just need to simulate their motion so that you can avoid them. Each moon has a 3-dimensional position and a 3-dimensional velocity. The position of each moon is given in your scan. The x, y, and z velocity of each moon starts at 0. Okay. One of the rather easy days? But C17R said, oh boy. That made me think that it's going to be a hard one. Simulate the motion of the moons in time steps. Within each time step, first update the velocity of each moon by applying gravity. Then, once all moons' velocities have been updated, update the position of every moon by applying velocity. Time progresses by one step once all the positions are updated. To apply gravity, consider every pair of moons. On each axis, the velocity of each moon changes by exactly +1 or -1 to pull the moons together. If Ganymede has a position of x is 3, Callisto's x of 5. Ganymede's x velocity changes by +1, and Callisto's x velocity changes by -1. However, if the positions on a given axis are the same, the velocity on the axis does not change. So it's a crude simulation of gravitation. Yeah. Once all gravity's been applied. You know what's interesting is that the velocity starts at 0, because I was starting to think, well, aren't they just going to fall into Jupiter and crash? Because I'm assuming it's velocity relative to Jupiter, right? Part 1 is easy, part 2 is harder. Day 2, part 2 is a lot harder than part 1 for me. Okay, once all gravity's been applied, apply velocity. Simply add the velocity of each moon to its position. Okay. Simulating the moons to produce the following. Someone's car alarm is going off. It's not my car. Someone else's car. The positions are all the same. Okay, because it's 0 steps. 1 step, it moved. Wait a minute. Why is the... Oh, because the velocity. So we apply we do the velocity and then apply it to the position. So it moved to 3 because it's less than than 3 other moons, right? And here's one where it was 0 because it's -3. Okay, I get it. I get it. Then it might help to calculate the total energy in the system. The total energy for a single moon is its potential energy multiplied by its kinetic energy. Potential energy is the sum of the absolute values of its coordinates. The kinetic energy is the sum of the absolute values of its velocity. Or we're adding all the moons together. Got it. There's a second example. Okay, they just give more examples so we can try it out. Okay, let's get my puzzle. No, not my puzzle input. Let me get the, it's not based on the int code thing at all. So let me pick one that was clean relatively. Was that 10? Yeah, 10 was the asteroid one, right? So it's relatively small. So let's grab 10, 2. Actually, you know what? I'm going to check the puzzle input. That was multi-line, and so was 10.2's code, right? Multi-line? Yeah, so I'm going to take 10.2, make that 12.1, and update the current task to be, we're on 12-1. Just use a clipboard to store the inputs. That sounds smart. I'm providing them as the example input here. So grab that, go to the example input and paste that there. And update this to say 12.1, 12_1 and build. So you're going to start with simulate except 1 and then replace the input with the puzzle input? Yeah, I guess I could, or I could just go for it and not need the example. This one seems pretty simple, that I might not even need the examples. I could just go for it. So I don't need position, do I? Actually, let's use position, since it's maybe convenient. We'll just introduce the third dimension to it. X, Y, and Z. So that's introducing more of this stuff. How much? This? Not quite. Put cursors there and make it a Y, and then last Z. So now I have arbitrary ordering. Don't know if I need it. Oh, I should take the add from the last one. Right, the plus equals. Put that in here. Make this as, oops. Come on, multi-cursor, work with me. There we go, Z. Okay, I don't need, raycast was fun. I kind of don't like deleting it, but I have it in the other place anyway. That one was fun. That was the asteroid detection and destroying one. Okay, so open the input file and read in the moon positions. So we have right, this one just stored it as line. So we'll have position Actually, there are two things I want, right? So can I just make another structure? Let's call this, instead of position, let's call it vector. Capital V, so it doesn't get, well, that might be not, that might be ambiguous. Let's call it 3D vector. Vector 3D. So struct moon. Vector 3D position. Vector 3D velocity. What's your vector, Victor? I don't remember that whole dialogue, but that's from the movie Airplane. It was Victor and Roger and I forget the other guy's name. Clarence, yeah. We have Clarence. So here we're going to have moons, right? And then for every line, let me double check. Yeah, so, okay, we have to parse this in a strange way. I'm going to do it with a single scanf, because that's how I roll. So, moon, should we just assume the input's good? No. Assuming makes an ass out of you and me. scanf line dot c string, we expect x equals some decimal, comma space y equals some decimal, comma space z equals some decimal there. Address of moon dot position dot x. Thank you for that follow. I didn't see who that was because I went too quick. Okay, so if that is not equal to 3, then we got issues, right? Let's just standard error. Invalid input. And then return exit failure. Otherwise, we're gonna take the moons and move the moon into it. You should start trying getting into running it. If you disappear, you'll know that your computer has crashed. You found your old Vulkan experimentation code? Uh-oh. Oh, there's something wrong with your stream? I am not dropping any frames. Knew we didn't have a problem. Yeah, sorry. Not much I can do about it. Do I have the stream transcode options today? Let's watch my own stream for a second, see if I got the stream options. Do I? Oops, I hit the clip button. I got the stream options, that's nice. What really sucks is when you don't have the stream options, and then you force everyone to watch at 2 megabit. Yeah. That happens, I try to restart my stream if people tell me about it. Yeah, ZU is size T. So size T is usually what you get for lengths, although this is old code. Lengths and sizes of things in C++ are generally size T, if I was being explicit here, right? So that's the printf or scanf for size T. It's a C++ thing mostly, although I've seen it in C as well. But traditionally you'd use just unsigned, and it would be unsigned int. That's basically saying it's whatever the size of T is, which is ironically the definition of size T. It's whatever size that returns. It's C, but I've seen traditional code just do that, and or make it signed, make it a D for decimal. Anyway, we're not doing that, right? There's no map now. We have the moons. Reading the moon positions. So the velocities will be 0 like the problem wants us to be. And then we're not doing this anymore. We're not destroying asteroids. Let me verify that this works so far. So done with that. Go to here, go to 12.1. Copy 12.1's. Oops. I hit 1 way too many times there. Event a code, so it didn't give me an error, so we got positions in there. All right, and then the problem wants us to simulate 100 steps, right? 1,000 steps. But if we wanted to try with one of these examples, they do it to 100, no, to 10 steps. Let's do to 10 steps. So simulate the motion of the moons over a certain number of steps, and we'll not hard code it. We'll make a constant here. Const expr total steps, or max steps, I guess, is 10, and then just for the purpose of checking, we'll overwrite our test input with that to begin with. Okay, I need to give it a type, don't I? I need to call it constant, not hard-coded. I know what you meant. Yeah, you know me, I don't use the right words. I should have said, let's not use a magic number, but let's define it to be a constant so we can change it. Well, TSJAWS, the compiler does end up making that a literal in the assembly language, so if I made it a volatile, or if I changed it, then it would not be a literal anymore. But I know what you meant. I'm just giving you a hard time. All right, so for a step, does a step number actually matter? It doesn't. So I'm going to use underscore just to hammer home the point that we're not using the loop variable. And each time we're updating the velocity and then applying it to the position. So for auto moon in moons, they never crash into each other, do they? Gosh, I hope they don't. We shouldn't assume that they don't, though. So I should know what moon number it is, because it shouldn't apply its own velocity. Actually, it can apply its own velocity to itself. Yeah, there's no harm in that. So for const auto other moon in moons again, we're going to count the number of well, we're going to accumulate a delta, right? So that'll be a vector 3D delta velocity. If moon.x is, actually, I don't even need to do a comparison. I can just take their difference divided by the absolute value of their difference. So const auto dx is moon, well, it's other moon x minus moon x. And I have to put in here a velocity. And then do the same thing for the other two dimensions. Click, 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 Y down Z. I love the multi-cursor thing. So once we have that, we're going to add that to delta velocity, right? Delta velocity x plus equals dx. Actually, can I just make that its own vector? No, because I wanted to do that divided by absolute value of dx. So ABS is absolute value. I need to have math.h, which I do. Okay, and that there and there, put a Y down Z. So that is the delta to apply for that other moon. And so that's adding to there. And so when we get to the end, we just say moon dot velocity plus equals delta velocity. And then we say moon dot position plus equals moon dot velocity. And we're done, aren't we? And what does it want at the end? I guess we could print out that at the end. Well, we just print it out every time, actually. I guess we can do it here. No, we can put it up here. Maybe I will use the loop variable. Step. Okay, so printf. We'll make it look like their output there. After, oops. ZU steps. And they, well, they haven't, if I want to make it exactly the same, I'm going to want to printf at the end of an empty line. And this is going to be step plus 1, because we start at 1. Humans start at 1, not 0. We're not going to print out that after 0 steps. That's foolish. Who cares? Printf. That, okay, yes. So here, let's delegate it to Moon. Moon.report. Moon report. Void report const printf. Pos equals x equals %d, y equals %d, z equals %d. Actually, why am I doing it that way? Well, this is a nice field trick. Mine's not going to look so nice. Let's do it this way. Let's make it return a string. And we're going to return pos equals %s. Actually, I don't need to do this. I can just say, oh, wait. I don't have a C++ version of sprintf, but I can use ostring stream. S-stream, actually that goes there. Standard ostring stream buffer, we're going to end up returning buffer string. Buffer pos equals position.report comma space vel equals velocity dot report, and then new line. And I suppose we can do that. And then I need a similar report for vector 3D. Similar buffer thingy. And this is going to do a little chevron, and then the other way. X equals X, comma, space, Y, Z. Velocity or gravity? It's velocity. We're not recording gravity. You're recording velocity and position. Moon is now banned and has been removed from the solar system. Okay. That looks okay. I need to do the report here correctly. It's printf %s. Let's have the new line be outside of this. So I'll remove the new line from here. There. And try it out. Okay, I didn't do it right. I missed something. Pluto isn't a planet. What did I do wrong here? Actually, it crashed, didn't it? So there's a crash somewhere here. Let's set up the debugger. What's the error? There's no error, it just crashed. So we're gonna look at it in the debugger. What were we on? 12.1. Run. Oh, I'm running the wrong one. Clear breakpoints, run 12.1, go. Okay, that's the error. Division by 0. Oops. Let's make a function to do the equivalent of this. It's really the sign or direction, right? Int direction of magnitude. So we have to be very careful if it's 0. Magnitude equals 0. Then return 0. Otherwise, return magnitude divided by absolute value of magnitude. All right, so that can just be direction of that. All right, did I get the same output that they did? I did not. Let's look at the first step. It's wrong after the first step unless... Did I get... No, this is the first step. Yeah, it's wrong already. The velocity is not... Hold on, why is the velocity all zeros? Oh, velocity is all zeros. For some reason that plus equals doesn't work. Or, okay, it might be that it's all zeros here. Oh, isn't it position, not velocity? That's probably what it is. Did someone tell me that and I didn't see it in chat? Did I initialize 141 vector? It self-initializes all zeros, but yeah, the problem was it was doing velocities, not positions. All right. It didn't work. They're all flying out into space. Probably because I got the sign wrong. 3, -1, -1, 2... No, this is wrong. Oh, it applied it after this one. It's not applying them simultaneously, so I can't do that. I need a copy of what the moons were previously, and we can't apply them right here until we get out of that loop. I guess we'll have a new vector of moons? Sure, why not? So we can do it here. New moons. And we'll make this a const so that we don't modify it, so that we'll get an error here. So instead we have to say moon, new moon. And we can reserve memory for the number of moons we have to be nice. Actually, if I was really clever, I could just reuse the vector. Actually, that's what I'm going to do. I'm going to have this outside here, and we'll just use swap. So, I can just use the, which moon it is, right? Actually, if I clear and then push back, it reuses the memory, right? So here I can just do, new moons clear. And then, new moon moon. And I should make a default copy constructor. Oop-a-doop-doo. Yeah, okay. Actually, this will have a default copy constructor. This will not because... Why? Actually, why doesn't it have a default copy constructor? It does. Okay, so that's not the problem. It's just new moon. And then I can do that, but then I gotta put it into place, so... new moons, push back, standard move, new moon. And then when we get out here, we do moon swap new moons. There we go. All right, does that look like it? No. How about after one step? Okay, we're getting there. The velocities look good. The positions do not look good, though. It didn't actually move it. It's the position from step 0. Oh, because it's delaying the velocity by one step. That would explain it. Now are we good? Looks like it. Okay, cool. Now I just need to calculate the energy. So sum of the absolute values of the positions and the sum of its velocity. Okay, so I should just introduce a how they do the number spacing. Yeah, I thought about doing that. You know what they're doing is they are figuring out how much space every number will need and then making the field that length. It's a cumbersome trick to do because you got to loop through all 4 and say, oh, the longest is 3 characters, so now make everything 3 characters wide. And I'm like, at first I'm like, the OCD part of me is like, I should do that, but then I'm like, I'm not gonna bother. One interesting thing is they have at least one. They had this. The field is at least 2 long, but sometimes it's 3. When it's 3 consistently. Weird. Why would they make it? Why would they have this field be at least 2? Why not make it default to 0 or 1? Yeah, I don't know. Why am I trying to figure out what they would have done? Anyway, let's get the energy. So let's put it here. Int energy const return absolute x plus absolute value of y plus absolute value of z, and then calculate the total, what is it called? Energy in the system. So int total energy. So again, we're going to loop through all the moons. And then we're going to print at the end total energy in the system d total energy. Total energy. Come on, editor. Plus equals moon dot position dot energy times moon dot velocity dot energy, right? Now what do I get? 179. Is that what they got? Yep. So let's just do the second example just for giggles. This one. Also 179? No, they went 100 steps. So let's change it to 100. $293. Nope, I did something wrong. Is the input the same? Did I update the wrong place? Hold on, what did I do wrong? Let's put that to a file so I can look at it easier here. Out. Oh, wait a minute. It's not reading the correct out input. Huh. Where did I write it to the wrong file then? Oh, I put it in the wrong place. I overwrote my own stuff. That's our That's our real input. I overrode our real input, not the test input. So that is that. 1940, 1940, and the positions look good. All right. So ready to run it on my own input then. So that's 1,000 steps. Build and copy our real input. And there's our number, 10,664. Yay, I got a gold star. Yay! That took 32 minutes. Good luck with part 2. Oh, you're not inspiring confidence, TS Jost. All right. That looks all good to me. Get to push that. Oh, let me write down my time. Where are my times? There are my times. 12:1. 32. Do I save? Oh, I'll give myself the 6.84 seconds extra. Just say this part is hard. The answer is 42. Yeah. What is the question? Clearing the stopwatch and running it. Let's move to part 2. All this drifting around in space makes you wonder about the nature of the universe. Does history really repeat itself? You're curious whether the moons will ever return to a previous state. Oh yeah, thank you, T.S. Jost. Why am I always forgetting this? So bad at remembering things like this. Let's see. Current task. Badoom. Okay. So you can farm points. Yeah, you gotta get those points somehow. Gotta catch all my mistakes. That's true. Just looking at where the beast is sitting. He's not in a circle anymore. He's like crouched off to one side. Brute forcing. Uh-oh. Determine the number of steps that must occur before all of the moon's positions and velocities exactly match a previous point in time. For example, the first example above takes 2,772 steps before they exactly match a previous point in time. It eventually returns to its initial state. Yeah, look at that. It does. Of course, the universe might last for a very long time before repeating. Here's a copy of this second example from above. It takes 4.7 billion steps before it repeats the previous state. Clearly, you might need to find a more efficient way to simulate the universe. How many steps does it take to reach the first state that exactly matches the previous state? What's the Monka S for? You mean because it looks so difficult? Time for some coffee? So yeah, I can just run it until it reaches its initial state again. But the hint is that to find a more efficient way to simulate the universe. Okay. Let me think about this. Is it the same input as before? So let me look at the output that we got. It looked like it was converging. Let's take 12.1 and make a copy first. So I can modify the output a little bit to do a little bit more inspection. Source main. Build. There. Done. Go to here. 12.2. Copy this and run. Whoops. Run it. Okay, so looking at this output, let me add, let's calculate the energy every step. Can you move the terminal to the right a bit? Oh yeah, sorry about that. I keep forgetting the beast cam gets in the way. Thank you for that. TS Jost. Want to see the output. Yes, you should see the output. Actually, but do you really want to see the output, or do you want to see a cute kitty? I don't want to move the beast. He's a very resident sleeper right now. You want to see both, that's true. Let's make this a nice... Actually, let's just move this here. I want to see it. Every step. Every step. What? Pin and pin that. All right. Does the energy converge at all? No, it's all over the place. Look at all those neat emotes that you got. Are those the standard? Yeah, the haha ones. Ones from Christmas. Or should I say the holidays? Hey there, Tim. How are you doing? I'll give you a shout out, Tim. If you don't know Tim Bodette, now you know that he is a streamer, and you also know how to say his name. He has made his own game engine in C++, and he uses it to build his own games, and they're of racing themes. So, racing a race car around a track. He's working on a game called Turbo Boom, which TS Jost made an excellent... What was it again? Not just video. Premiere, preview, marketing, teaser trailer. That's it. So you should check out Tim's channel where he works on Turbo Boom and other games, and shows you his entire process of doing game dev, even like the accounting of his time and stuff. It's pretty inspiring, I think. Okay, I'm analyzing problem 2, or day 2, puzzle number 2, Tim, on the admin of code. So that's as far as I am now. And this one is simulating the orbits of, it's in a simplistic way, the orbits of moons around Jupiter. And then it's asking the question, how long does it take before the moons get back to their original positions? And it's describing that it can take a very long time based off of the input. So it could take an extraordinary number of steps. And it's hinting that we need to look for a more efficient way to run the simulation to find out when we get back to our initial position. Yeah, so I'm guessing that if I did run this brute force, we wouldn't get the answer. Although I'm kind of curious. If to run it brute force, I'm going to want to remove all these prints, right? So let's do that. Let's comment out the prints. And rather than going to max steps, we're going to go until the moons get back into their position, right? So we're going to do a do while... We should remember the initial positions, right? So let's make a copy out here somewhere. Auto original moons equals moons. Just do a brute. That's what we're gonna do. We're gonna do a brute force. Try it. Yeah, and if that's not the right answer, TSS, then I gotta add 1, right? And then try again. Do a binary search on the API. I thought it was initial position. Oh, a previous state. Interesting. So it might not reach the initial position. It might go into a loop. Okay, that's different. Okay. But are we only interested in the positions? Or is it the entire state? And positions and velocity, so it's the entire state. So how dense could I make the state represented by? is it really going to be 8 vectors? It's going to be 24 integers. I guess I could hash it and just collect hash numbers. If I say the wrong thing, the beast is going to wake up and bite me. Make a hash table. Yeah, that's what I'm thinking. So, I don't know. Yeah. So would we have to record every state? It doesn't care if it hold on. I'm just worried about hash collisions. It just cares about number of steps. So I can just be optimistic that we're not going to have a hash collision. Or I could just fill up my RAM with recording the entire state and make the hash the key. Actually, if the numbers aren't that big, we could just string them all together into one monster string. Yeah, that's what I'm thinking, Enduran, is just string them together. It's not even a hash anymore. It's actually just an encoding of the state. What if we just do that to begin with? Simulate the motion of the moons until we see them in the same state twice. And then we actually do need to count, right? So we're going to have a counter, step count, initialize it to 0, and add 1 here. And then we'll have just a set of... no, it has to be a map, because we need to remember how many steps each one is at. Standard map from string to size t of state history. And then that means I'm going to want to, I guess, add together, to encode and then add together all the moon state. So O string stream buffer. And then, actually, that's not a nice name, is it? Moon state buffer. Okay, and then for every moon, we're going to have it here. Moon state buffer shift in new moon state or encode. And let's put in an extra delimiter between them. Comma? Slash? You need to know the steps from 0 till the first hit, or the number of steps between the first hit. It's the number of steps to reach the first state that exactly matches a previous state. So it could go along a path and then loop to a previous point that's not the first point. So it's the number of steps from the beginning until it hits itself, basically. So I'm going to want to know what the step count is at the end, but we're not going to compare with the first state. We're going to compare with all the other states. It's not, yeah, it's like Toulouse said, the number of states from 0, but the number of states from 0 to any previous state. So we get that in there, and I'm going to want to say state history moon state buffer string equals step count. Let's do that after we increment the step count. And then we're going to say, check if this, actually, let's get this out as another string. So const auto moon state is that. Check if this state was, actually we need to do it before we insert it, right? Yeah. So, simulate the universe. Simulate the universe. Okay, we can do it to this point, right? Check if the current state of the universe. Now, I need to do it in big capital letters with spaces between them. That's important. Check if the current state of the universe has occurred previously. And don't I need to include the initial position, don't I? So really I want this to be route out here. Pull that out from there, and that's moon. Actually, it's new moons, isn't it? Or we could swap it first, right? Yeah, we can swap it first. The reason I'm doing this is because I'm going to save the initial state up there too. Okay, so take that. This is going to be a whole string. Encode universe. Return state. Let's return this, right? Okay, and then moons is this guy. We don't need to make a copy of it. And then I just need encode for one of these. Kind of like report, isn't it? What if I just use report? Well, yeah, why don't I just be lazy? It's going to have extra characters in there, but who cares? Does the stream drop frames due to memory usage first? No, because my program will only use one CPU core. So it should only, I have lots of reserve CPU. Thanks for the follow, the real? All right. We need to seed this, right? State history of encode universe moons equals 0. And then it's repeat this down here. Step count. Okay. Oh, wait a minute. We need the encoding first, right? So do that. If moon state is not equal to state history, actually I need to do a const auto state history is entry is state history dot find moon state, and then say if that is not equal to that dot end, then we can break, right? So might as well just make this an infinite loop, foreshadowing what will really happen. And here we'll just break out, and then we'll say printf first state that exactly matches a previous state was found after ZU steps. Step count. do that. And then we don't need to do this one. Add the... Actually, you know what? I can just move this to the top. Yeah, why don't I do that? This can just go up here. And then that's step count. That's easiest, right? Record the current state of the universe. Will they all be 0? I don't think we're following the laws of conservation. If we were following the laws of conservation, then these numbers would all be the same number, wouldn't they? And it wouldn't really be 0. I guess unless, well, we're not showing after 0 steps, but it starts at 0 because all the velocities are 0, right? Anyway, just want to let it run for a while. Let's run it in the debugger. So debug, because I have a feeling that it's just going to take forever, and we'll have to abandon this approach and find an easier one. 2, 2, 2, and 2. Run. Yeah, so it's running a long time. Let's go hit a breakpoint. Now, how big is our state history? 31,000 and counting. And then each entry here has, oops. Let's look at it here. Can I make that bigger? Each entry has a complete state as a key and then a number of steps. Yeah. So yeah, what'll happen first? Run out of memory? Or will it find the answer? Actually, I might as well put a breakpoint there. I think we're going to run out of memory before it finds it. 82,000 and counting. Clearly, there's something bigger happening outside the system, but still affecting it. 121,000 and counting. I mean, I guess I could do that. I have a feeling, though, this is never going to hit the answer, even if I made a release build. It'll probably run out of memory first. Out of curiosity, let me look at the memory usage of the thing. Let's find its memory usage. Oh, I can't minimize one. Okay, I'll just move it over there. There's its memory usage, 100 and... Actually, it's not growing that fast. It's at 111 megabytes. But it's a ramp function, obviously. And it's only using one CPU core, like I said before. I can make a release build and it'll probably run 10 times faster, but still won't find the actual solution, right? But yeah, so 30 years to complete. Yeah, no problem. We do need to keep all the previous states, GSJOS, because how will we know if we hit it again? And then when we hit it again, like, unless you're assuming that we'll hit the first state. No, it's not about the initial state. It's until you reach the first state that exactly matches a previous state. So it could be any previous state. But even if it's the first state, like, yeah, sure, yeah, then you wouldn't need all the memory. Yeah, it is annoying. So we have to remember all the steps, all the states we were ever at to see, and then the comparing is going to get slower and slower. But yeah, okay, so I don't know if I'm going to be able to solve this problem because I'm not a really good math guy. I guess I could study the output and see if there's a pattern or some insight into it. I guess that's what I'm gonna do. At least build and take a break. Yeah. Out of curiosity, do I remember enough to know how to change it? I think I go to my CMake cache and I do this. It's just this string right here, debug. And I turn that to release, right? And then just rebuild. And then I think I do want to do what Endoran said and actually print something. So what point do we want to do it? Maybe out here? If, well, give some visual feedback about progress. If step, hold on. If step count mod, how optimistic am I gonna be? It'll probably do 10,000 in, so let's do, 1,000,000 becomes a printf end of line. If step count is just 10,000, then let's print a dot. Actually, let's print that and then do the number. And we should do it before we add one, actually. Count this step. Because I'll want to see the 0 one. Let's... How many digits do we want? 7, 8, let's do out to 10. Yeah. I forget which one's left or right justify. If it's... I think that'll right justify it, right? Step count. Alright, let's see what it does. So every dot is 10,000 steps of the simulation. And it should go 100, and then that'll be 1,000,000. Found a newest sound effect for my stream bot, by the way. I don't have sound effects, but I will note that down. Oh, that's for Tim. Okay, Tim can use it too. But it was my voice, so I can use it too, right? Should go to 100. There we go. So it filled to the end there. You can't see because it's in the way. Just enough space. Actually, let's shorten it a little bit. Okay, I'm gonna go get some lunch. Just kidding. It could go into the billions, right? So why don't we let it run while I try to think of a better approach? When am I gonna add that emote? I was thinking about it yesterday. I don't have a Twitch emote slot, but I do have BTTV and FFZ. I could make it one of those. You let this run and develop for a better solution? Yeah, that's what I was thinking. Let it run and let's see what happens first. Either brute force will give me an answer, or I will find a better way to do it. Hey, the Red Sky one. We're trying to solve Advent Code Day 12 puzzle number 2. Okay. The way this is working is it's taking these numbers and updating them based off of gravity and then applying them. So the positions are just really accumulations of the velocity, right? And the way that... Hold on. The way that they talked about it, it does return... These are returning to the start. Do we want to just assume that at some point the velocities will all become 0? I'm not smart enough to tell, like, will it always be a complete circle, or will we do something like that, where we start way out here and we end up here in a tight loop here? I can't think of it. Oh, I see what you're saying, TS Just. Does it tell you too high or too low, so I could do a binary search? Now I understand what you were saying before. But that sounds like it's cheating to me. Is that what they expect people to do, though? Just use binary search on the answer? Will it at some point tell you you stop guessing? Is it a minute every guess, or is it double the cooldown? Oh, I see. So it increases the cooldown. Got it. It would be creative using the API if they didn't have the cooldown up to 5 minutes, right? Hmm. I have no idea. I really don't know. I might need a hint, but let me think about it a little bit more. Yeah. Yeah, it can't be negative. That's true. Let me see if they oscillate in a certain way. 3, 5, 6, 3, 1, 0, -1, -3, -6, -6, -3, 0, 3, 4, 5. They do tend to oscillate, don't they? Like even after 1,000 steps. Like they don't get really far out of range. Actually, the positions might, but the velocities don't. These are they're oscillating. But then it talked about that to find that there's a more efficient way. Find a more efficient way to simulate. So the way we're simulating right now is we're comparing like 2 with 3, 1, and 2 and saying, well, that's +1, -1, 0. So we add 0 to -3 and it stays at -3, right? And then so we're updating the velocity and then accumulating it or integrating it into the position. Are they sine waves? Where if you don't know what you don't know, you're going to have a very hard time. Velocity is now forced to 3 digits in the output instead of 2. Yeah, my own output here. I could reduce the problem space down to 2 moons. What would it do, right? Won't they just go back and forth? Blatantly lying? You think so? Or do you know so? Oh, wait a minute. Did it crash? I think it crashed. Probably ran out of memory. Because it didn't print anything, right? If it had not crashed, if it would have reached the end, we would have gotten a print statement. So I think it ran out of memory. Uh-oh. Let me run that again and watch the memory usage. Where's that window again? Here it is. Find it. Yeah, it's a steeper climb in memory usage. It's a 64-bit program though, right? Where does it say that? Oh no, it's 32-bit. See, when it gets to 4 gig, it's gonna crash. Why is it 32-bit? It should be 64-bit. That's weird. Download more RAM, yeah. It bothers me that it says it's 32-bit. It shouldn't be. Is this kit wrong? I did that. That should be 64-bit, right? Wait, what's the difference between these two? Uh-oh, maybe that's the problem. Oh, is that 32-bit and that's 64-bit? Well, that would make sense. Let's change the kit then to use this one. And build it again. Well, that would explain why it crashed. It reached 4 gigabytes and then stopped. Yeah, we're getting a bunch of other problems now about types. Do I have any problems with number 12 too, though? Don't know. Doesn't look like it. So some of the other problems had differences here. Oh, because those were ints, not ZUs. Okay, well, maybe I should go back and fix those at some point. Anyway, 12.2 didn't have a problem. So I should be able to run this again. And now it's 64-bit. Using up all of one core. I should probably watch that in the corner while I'm thinking, because I don't want to exhaust all my memory. How much RAM does it have? Good question. Can I show that? Physical memory, I got 32 gigabytes. So now it's using... Interesting, it's using less memory to start with than the 32-bit build for some reason. Or maybe just because I wasn't watching it as much. Is it slower? Is it doing a debug build? It's doing a debug build, that's why. Okay. That makes sense. Make it release, please. Now it's faster. And where is it? Here it is. Okay, yeah, now the memory's climbing much faster. Okay. 64-bit release build, but it's not what we want, right? I'm wondering if the total energy in the system is a hint. They're not going to have printed that in their example. They're just printing the position and velocity. I'm starting to think it's in the pattern. It's in the oscillation of these numbers. 3, 5, 6, 3, 1, 0, -1, -3, -6, -6, -3, 0, and 3, 4, 5, 2, 1, 0. Yeah, I'm ready to give up. unless my computer can do it with that before it runs out of memory. We're at 700 megabytes and climbing. Can't brute force it. Well, I'm not going to get an answer then, probably. It did fill up your RAM and it crashed out. Answer's like 12 digits long. Yeah, as long as you have enough force. It's at 1.1 gigs and climbing now. I should just put that up here. Looking at it. Had enough time? Yeah. Okay. It's something in the numbers, I'm sure. The numbers, what do they mean? You know, it just occurred to me that all three dimensions are independent, so we really don't need to simulate all three. We only really need to simulate one of them. So I could reduce it down to just the x dimension, right? Maybe that's where I start. I just record the x coordinate. I don't even bother with y and z. Is it possible that they'll reach the same x coordinates but different y and z coordinates, though? I don't know, I can give it a shot. Kind of curious how far this will go before it crashes. Actually, I want to see how much memory it uses at 7.5 million. Because that's where the 32-bit hit the limit. It's at 2 to the 31, isn't it? When it reaches that many gigabytes or that many bytes. And this should continue going until I run out of memory. And if it's safe to assume that that it does go back to the beginning, then I don't really need to save all the memory positions, right? Yeah, I think we're done looking at this one. Yay, I got all my RAM back. All right, let me make an attempt to reduce this down to just the y and z coordinates. So let's hack out the y's and the z's. Actually, do I need any of this junk? I don't. I just don't want to use Vector 3D anymore. Okay, so we're going to just discard. Hold on. A moon is just an int position and velocity. And we can just make the report just the two numbers, right? Position, velocity. Actually, let's do a comma. Every nth interval check against the file. Okay, so this is just position. And we can discard those other numbers, right? So int y, z. Okay. And then, so this is just d. This is just an int. This is just plus equals direction of d. Okay. Hey there, Clayman. How are you doing? I never waved to Tim either. Oh, not nice of me. How many years is that going to be then? Your answer is 15 digits. Beast is moving. I think he's just rotating though. Doesn't seem to be going any faster, but it's probably using much less memory, right? Did I build it? Oh no, it didn't build. I'm dumb. I'm dumb. Thank you for that follow. It didn't build because there was a bug here. Oh, uninitialized variable delta velocity. Wait a minute, what? Oh, I didn't initialize it to 0. That would be a problem. Okay. It is faster. It's probably using much less memory. But it's only looking at the x coordinates now. But yeah, if it's 15 digits long, and we're only getting to like 8 digits or 9. Yeah, I have a beast cam, Clayman. What do you think? What's the memory usage look like right now? It's faster, but using a memory just as much. All right, well. They are independent, so we could just look at one coordinate and not the others. But what's up with the x's? What if I reduce the problem to just 2 moons, what does it look like? If I reduce it to 2. Let me unhack this, because I have a suspicion that we'll actually have to look at all 3, because it's possible to have all the x's come together but the y's and the z's be different, right? Oops. There we go. Yeah, I was just going to reduce the number of moons. Input. Let's just destroy 2 moons. Oh, 48 steps. So we can put the prints back in there and see that. Step. There we go. We don't have a... Oh, we have a step count. So we do reach the original point. Right? You're going to give Tim the hint, but not me? All right. What if we had 3 moons? $120 steps. Interesting. So it's just that 4th moon. What if I just compare the moon 1 and moon 4? 16 steps. And moon 1, 2, and 4? 264 steps. Huh. You want to spoil it? Well, I guess I'm ready for the hint. Well, I don't know. Is it cheating to get a hint from someone? I could put this one on hold and go to the next day. You don't need the hint. Okay. If I don't need the hint, then maybe I will come back to this one. Unless there's something special about these numbers. Like, if there's only 3 of them, it any combination, it comes back to the original state pretty quickly. What is it with having 4? What is that doing? Sure, each axis is independent, but when I just had it go through the x-axis only, it was still going to run out of memory. I don't think it can actually simulate down to a 15-digit... Unless we just don't store the memory at all. Okay, so maybe maybe I just make the leap that we're going to end up with 0 velocity again. It should be found quickly. With each... and just looking at one axis? Okay, just out of curiosity, what happens if I stop tracking the state? And I'm just just wait until it reaches 0 again. And so don't encode that, don't do that, and don't do that. Instead, say if, well, I gotta sum together. Let's just, not sum together. I need to look at all the moons. So on 0, false. Actually, I can accumulate it out here, can't I? I can put it up here. And I can say, if, now before I move it, if, let's comment these out again. If new moon dot velocity dot x is 0, or not equal to 0, or y is not equal to 0, or z is not equal to 0, non-zero, actually that's just what non-zero equals. It starts out as false, and then when anything ends up being non-zero, that goes to true, and so this will be, if not non-zero. Right? How fast is this? That's what I'm just curious about. Oh, that's really fast. And we're not using memory. But is it fast enough? It's gonna get to a nine. How many? 1, 2, 3, 4, 5, 6, 7, 8. It's gonna get to 9 digits pretty quick. Maybe it might still be too slow. If you're saying it's a 15-digit number, that'll still take a long time. What's this, by the way? This is the advent of code. So I'm on day 12, part 2. 1-axis shouldn't be such a big number. Infinite loop. I don't think it should be infinite. Going back to this input, if I remove a moon, it does converge quickly, right? Yeah, 60 steps. Let's go back to only looking at one dimension. Now I kind of wish I had stashed that. That's just an int, and we're not. I'm just going to comment out report since we don't use it. I was looking at all dimensions again, yeah, but now I'm going to go back to looking at one dimension, so I don't need to encode the universe anymore. And we'll put this back into y and z. Oop, that needs to be in there. Hold on. Ah, I messed that up. Ah, there we go. So just, yeah. Just d, just velocity, just one number instead of 3. Now it's one dimension again. You can check for repeats for each axis separately. Okay. What did I do wrong here? This is an int. That has to be initialized to 0. I made that mistake again. All right, now how fast is it? I think it's still too slow though, right? Let's go an order of magnitude up here. And let's go to 15 digits. And I need to make my window wider. So that's 100 million. Right? 4, 5, 6, 7, 8, 9. It's still going to take a while before I even get to a 10-digit number. Go another order of magnitude up in how we print. So now each dot is 1,000,000. And every line is 100 million. That's still going to be too slow. Cycle for each axis shouldn't be anywhere close to this large. So I'm doing something wrong in the math, you're saying? We're just using the x coordinate, right? And then we're just taking the velocity that we're looking at every moon and taking its position, subtracting the position of another moon. And if it's of itself, that it'll be 0. And so it'll just be no op, right? Direction. It's just taking, it's either going to be 0, 1, or -1, right? Taking the moon and adding to its velocity, and then adding the velocity to the position. You mean the direction function? Yeah, I guess so. We can just say it's greater than or equal to 0. Else if magnitude is greater than 1, return 1. Else return -1. But I still TS is saying it should go back to all zeros at some point long before this happens, but it's for some reason it's not. Unless that that flag starts at false. Every loop it starts at false and it becomes true if any number is not 0. Yeah, I need to take a break anyway. I'm going to let this run while I take a break. Greater than or equal to 1? Oh, yeah, you're right. Thank you, St. Lucifer. That was up here, right? Equal to 1. Or really greater than 0. Maybe the compiler will just fold those into the same comparison. That did build, right? Let me let this run while I take a break. So I'm just going to hide the camera for a minute. I'll be right back. I'm back. One thing I didn't check. Did I look? Am I looking at position or velocity? I am looking at velocity. I don't know what I'm doing wrong. Magic hand. I don't know. This will count forever. So are we checking at the moment velocity is 0? Yeah. Maybe your solution doesn't go to 0 velocity, but that's the initial point though. If it doesn't return to 0, if it's repeating at some other point, that means I have to record all that state and then I'm going to run out of memory. Won't I? Not going to run out of memory. Yeah, that's what I'm thinking, Super. I mean, TS-JAWS is kind of leading me to believe that I can still brute force it if I optimize it down, but I don't know. He's saying the cycle isn't that large, but if the cycle isn't large, I could brute force it. But if I can't brute force it, then that means the cycle is too large. Per axis really just divides the work and memory by 3, though. It's not even an order of magnitude faster. It's a third of an order of magnitude faster. Yeah, 400 trillion would be how many digits? Yeah, if it's 15 digits long, this is probably it'll find it eventually, like maybe sometime next year. It's not just divided by 3. Well, is that a hint? These axes, each axis is independent. If we're just dropping the y and z axis, we're doing 1/3 of the work. We're 1/3 of the velocity updates, 1/3 of the position updates, and 1/3 of the of testing for if the velocity reaches 0 again, assuming that that's the point it returns to. I keep coming back to thinking, is the total energy a hint? Huge. You're saying that, but I don't get it. I don't get it. I don't get it. So right now I'm just thinking about the problem in terms of if it was one dimension, and we just had these values for x, polling these other values for velocity x is polling the position x, and they're like four dots along a line polling each other. Yeah, I have no idea. Also, yeah, I'm just wondering if it'll just dawn on me, or if I'm just going to run out of time. I've already let an hour elapse. Maybe I put this on hold and do the next problem. Maybe come back to this one later. You also have little idea after talking. So TS-JAWS is just too smart, I think. Maybe I can see if my brother is really good at math, could do this one. Never read the problem too. The problem is, how do you know when the system gets back to it starts repeating in a loop? And the system is just you have 4 orbiting bodies that are pulling each other. So every step you take their positions along each axis, and you see like if there are, they count the number of things to the left, count the number of things to the right, take their difference and add that to the velocity in that dimension. So like at the beginning, well, it actually doesn't really matter. Take this x negative 13, right? There's one right on top of it in that dimension, but there are 2 others to the right. So it's going to take that 3 for x and add 2 to it. And then after it updates the velocity for every dimension and every moon, then it adds that velocity to the position. So negative 13. Negative 13 plus 5 is negative 8. 14 minus 2 is 12, etc. Yeah, if they use floats, we'd be in trouble, right? I'm just gonna call it on this one. Unless, what is that? Tim and Adam need to have a meeting. We can only have a meeting when all 3 of us stream at exactly the same time. If not, you'll instantly start another stream. You always stream for 47 minutes. Tim for 59 minutes, then for 71 minutes. Oh, was this common multiple? Is this what it is? Okay, I think what you're saying, TS Just, is that the axes are in the... Yeah, but this program is just considering the x-axis and it's still taking forever. Yeah, am I doing something wrong in my math then? Because this is only looking at the x dimension. It's tossing y and z. It's just taking the x's, and it keeps going until the velocity gets to 0 again. Something's wrong with the code? Okay. Well, 12.1 worked. I screwed it up somehow then, huh? Let's return to printing this out then. And then the report needs to be updated. I want to actually print something. Position, comma, velocity. Only one axis. We can't run it while it's... Can't build it while it's running. Okay, we can do that. So we're not using velocity 3D anymore. We need this in code universe again. Okay. And then we're bringing the state history back in here and recording it. And we're getting rid of non-zero. Non-zero. Bringing that back in and taking that one out. And getting rid of that flag there. Let's just have it print some output. Yeah, that's going to be too much. Oh, wait a minute. Is that the hint? The number's exploding? Why is that number so large? Hold on. That's an int. Why are those numbers so big? Okay, let's debug it. Oh, I can't debug it because it's the wrong kind of build. Go back. Well, actually, we can keep it 64-bit. I just need to make it debug again. Okay, see you, Ramy. You know what's probably going to be is after Ramy leaves, I'll figure out the answer. I'm being mean. Okay, after one step, what do the moons look like? Oh, the velocities are all... Oh, uninitialized. Dang it. That's what it is. These are not initialized. Okay, so if that was the bug, let me comment out the reporting, the printing. Always initialize. Thank you. Oh, let's remove some of these zeros. Something else is wrong? Put this back and let's look at the numbers again. Actually, I can just run it here. And then just hit, well, I should see the output, shouldn't I? There we go. I should be able to hit that. And what does the state history look like? It's really big. Okay, but still. But what does the output look like? Oh, it's lost. Let's actually let's just run it and look at the first few steps. Wow. Okay. Negative 13.3. Negative 13.3. Actually, I can just skip ahead, right? At 70 steps. Negative 3.3. Yeah, so it's correct. So the math looks good now. Do I just need to run a release build again? And then stop printing? Oh, there we go. So, how long does it take when it's not a release build? It's still going to take a while, right? Okay, so I can see how this is going, is that we find a cycle for each dimension, and then we take their common, or their least common multiple, or something like that, right? Okay. Jeez. We'll put it, we'll do release build, why not? We'll live on the edge. So it finds a match for X at that. Okay, so how am I going to write this code here, then? Oh, we just have to just brute force copy paste the whole thing? Do I ever use original moons? I do not. But that would be useful to start the simulation over again. Simulate the motion of the moons until we see them in the same state. Okay, we can actually do them concurrently, right? We can just have different histories for X, Y, and Z. 2 milliseconds in Rust? Actually, I'm curious to know if what it repeated at. So let's print that out. So printf found repeat of step number ZU, and that's this 1 second. I didn't screw anything else up here, right? Right, okay. 0. Okay, so I wonder if it always starts over. No, it doesn't, right? Because if we look at all 3 dimensions, it doesn't. Unless this step number isn't being recorded correctly. No, we are incrementing it. All right, let's look at the Y. Let's just hack it and look at Y instead. So let's just have X, Y, and Z prepared, even though we don't use them. Let's look at the Ys now. Oh, it's the velocity. The X velocities all go to 0 here. The Y velocities all go to 0 here. Yeah, so I can just hard code this for now. Y and just run it 3 times and then find the least common multiple. Is that the term? So I need to find where these numbers, I need to factor all these numbers. factor number. Oh, I want a calculator that does it for me. Online factoring calculator. Here we go. There we go. Find the factors of this number, please. Okay, those are these numbers. And then that. Oops. Here are the factors. Oh, wait a minute. Do I want... I don't know if I'm doing this right. I'm not a math guy. I guess we're looking for the ones that are in common, right? And then this number. No, I don't think I'm doing the fact. It's at least common multiple, right? Oh, I forget how to do this. I'm not very good at math. I guess I'll look it up. Least common multiple. We're gonna be learning some math today. Math is fun. Finding least common multiple. I thought it had to do with prime numbers, though. Oh, we just let the tool do it. Why learn math when you can just have a tool do it for you? Oops. Wait a minute. It's getting rid of my number. I guess I have to fill in the other two first. Oh, I broke it. Wrong order? Yeah, it's too big, I think. Thank you for the follow. I need to know how to do it for reals. I really should just be looking at the Wikipedia page, right? Stick the output in one of the inputs. Yeah, I think the numbers are too big, though. I mean, I could try that. Shoot. Let's go back to that. Calculator. Okay, here we are. I don't think it's gonna work, though. So that number and this number. Oh. So it's just broken. It would work if I did it that way. Okay. Wait a minute. There we go. Too low. So I did it wrong. Maybe my numbers are off by one, actually. The numbers might be off by one. No, we would have counted it and then broken out. Yeah. So those are correct, right, for each dimension. It's just maybe this tool's broken. Hold on, let me try this again. This number and this number is that. What am I doing? I should just collect these numbers to begin with. That number, and that one. So that's the least common multiple of these two. So then the least common multiple of this and this equals what? But then what is... Let's try this a different way. What's the least common multiple of that and this one? Right, is that number. And then what's the least common multiple of that and then the second number? I wonder if I'm breaking this online tool. Yeah, it's giving me different numbers. I think the tool is broken. Is there one I could just use that? C++ 17. So this tool is probably broken, right? Wait a minute, no, the 2 is missing. Is that what happened? Yeah, it's reducing it down for some reason. It's changing the number as I put it in there. Stupid tool. Okay. We're just gonna learn how to do this. I'm sure, I thought it had to do with the factors. Prime factorization, yeah. Yeah, can't I just find their prime factors? So, if these are the factors, that's not right, is it? 2's in there twice. Oh, 2 is in there twice, I see. How do I know which ones of these are prime? I want the prime. Go back, give me a better tool. Factor prime, calculate, online calculator, prime factors. Oh, okay, it's the same thing. Okay, there we go. Got it. Okay, see you, Tim. Maybe I should use Wolfram Alpha. No, I think this will do. I see where this is going. Get the prime factors, and then I find how they're converging. Do I want to do this in code? I don't know. So, the factors are obviously 2. It's 2 times 2 times 2 times that prime number times that prime number. Let's put them in order. Times this one, right? So I want... turn all the x's into... Let's get rid of this. Oops. All right, so it's this that I want to calculate. Scientific? Sure. 2 times 2 times 2 times 7,043 times 46,507 times 115,807. There we go. Return and put it in again. There we go. An hour and 29 minutes. But I don't even have the code for it, though. Do I want to keep going until I do it in code? So I had to take my solution and rotate these 3 lines around and running it 3 times, getting 3 different numbers. Then I use an online tool to find their prime factors. And then I took their prime factors and basically, it's not that you multiply them all together. It's that you, for every prime number, you take the highest, what's the term? There's 2 2s, 3 2s, and 1 2, so you have 3 2s. And then there's 1 each of these other 3 prime numbers, and then you multiply them all together, and that's the least common multiple. And that wasn't the number either. Can I go back and see what my number was? Here it is. Here's my answer. How many digits was that? 3, 6, 9, 12, 13. Yeah, it's a 15-digit number. Yeah, but I feel bad because I didn't, I don't have a program that gives me this number. Do I want to keep going and make the program do this? Yeah, I think it deserves it. So there are a couple problems you have to solve then, right? I need to have it run 3 times to get these 3 numbers, and then for every number, I got to get its prime factors. And then once I get the prime factors, I need to combine them, and then I need to multiply them. Ah, so much math. Okay, so I think to simplify this, we're going to use vector 3D, but they're not going to be X, Y, and Z. They're just going to be, actually, can I? Yeah, we'll just have, M3. And I will have a, constructor here. Let's just do a traditional constructor. M0 equals... Actually, what am I doing? I can just make that a vector of ints. And then just say that this is m.resize 3. And then, actually, why don't I be extra cool about this? We'll make this a template. Int vector, and then it's vector n, and then doing resize n, right? And then I class. I'm missing something here. Do I not put that in there? Yeah, okay, and then vector 3D just becomes vector. And then I have to do for auto D in M. Oh no, let's just do it the other way. For size Ti, I is less than m dot size. If mi is not equal to other mi, return false. Return true at the end. Okay, and then less than, it's the same kind of thing. For every dimension, if it's less than, return false. Else, if it's greater than, return true. And then only when we fall out here would we return false because they're equal. That should be an I, not a 1. And then plus equals, it's the same kind of thing. Mi plus equals other mi. Although I'm not using any of these stuff. Maybe I just get rid of it all. Do I have it back for the less than? Oh, I do. Thank you. Thank you. Toulouse? Actually, probably don't even need all this stuff, but it was just fun to do it anyway. Okay, so then moon. So I have the idea I have is that we can just we can use vector. Hold on, vector 3, and then get rid of these. I'm not using report. But we can just track which dimension that we're working on. So yeah, we can keep that. I don't need encode universe anymore. Or do I? Okay, so it's not encode universe anymore. It's encode dimension. Oops. Dimension. And so there are moons, and then there is a dimension in size TD. And oh, I do need the report. Oh shoot. Undo until I get it back. There it is. Redo until I get back to where I was. Okay, and then there's the report. We're only going to care about one dimension, right? D. So I guess we're just going to keep it simple and just do MD. Right? So it's D. Wait a minute. Moon needs a report. I got rid of that one by accident. Okay, so we add it back. This one is position.report D. Velocity.report D. It should have been okay with that. Inaccessible because it's a... Let's make it a struct. We don't care about accessibility, do we? Alright, so... we're putting this back to position.m to 1 and 0, right? Oops, I hit a weird key and it shunted it over there. Alright, that's 0, that's 1. I don't need this anymore. Hey there, Two Bud. Good evening, yes. So I have like about a half an hour before I have to go. Let's see if I can solve this problem the correct way without using online tools and junk. Alright, so we're going to simulate the motion of the moons until we see the same state twice for each dimension. And then we'll have those 3 numbers, right? So we'll need to have 3 different things right here, right? Periods, actually. Let's actually just use vector 3 for periods. Hey there, 715209. So I'm working on Advent of Code, and I solved day 12, part 2. with a lot of help from TS Jost and others in chat. But I didn't do it all in code. I did some of it using an online tool. So I'm going back and making my code actually compute the answer directly and not have to use online tools. So if you want to know what day 12 problem 2 is, well, you can't see part 2 until you've solved part 1. So I guess I should just show you this. Once you get the answer to part 1, they want you to take the code that you wrote in part 1 and like basically they tell you run it until you return to a state you were at before, but it's a huge number of iterations, so basically brute forcing it is impossible. I figured out a way to get that number, but it was not all in my code, so I'm trying to put it all into my code now. You can click the share at the bottom. I don't know what that does. Twitter. Yeah, I don't know where it goes. It might just say what I got on it. I don't really want to try that yet. Okay, so we're going to have 3 different state histories, right? Let's just keep it simple and put it into a vector. And make that 3. And then we'll say for auto. Actually, no, we have to count for size t. D equals 0. D is less than state history size plus D. The state history encode dimension that comma D. That's D. And then second level is the map. Right. Actually, I should only do this if the period is not known. So if periods D is 0, then do that. Dot MD. Record the state of each dimension of the universe for which we're still searching for a period. Okay, and then simulate the universe. Actually, it's the same thing. I can skip it if we already found it, right? So what if we just skip it way out here? If periods is known, then continue. Skip dimensions of the universe for which we already know the period. All right, and then, so I don't need this one. Record the current state of... Oh, I should just put the whole loop outside then. Wait a minute. What am I doing here? I don't need a vector state history. I can just clear the history and start over again. Yeah. Sure. We'll keep that one around. But we'll just move this and say that that's 3. And 3 infinite loops. How you like that? Okay. So we don't need to skip. Record the current state of the dimension of the universe currently being simulated. Simulate the motion of the moons until we see them in the same state twice for each dimension, sure. So that means that we can clear the state. Actually, we can have the state history just be inside there. We don't need to clear it. And the same thing with the step count. So there is no D here. There's no loop here. It's just that. The D is the outer variable there. Simulate simulate to one dimension of the universe. Correct. So we're only modifying the position. Let's use a different variable other than the delta. And then, yeah, get the direction, and then, yeah, this is just these .mds go in front everywhere. And then we'll move it, and we're getting some visual feedback. And then this is dot comma D again. And if we find it, then let's do a new line here. I forgot to do that before. This printf goes inside here. Let's just see what this does. The wrong D variable, probably. Yeah, you're right. So I let the compiler figure that stuff out for me. That, right? Thank you. What's wrong with this one here? Oh, because this is just delta velocity. Okay. So now this should run the 3 dimensions independently. Yep. And it is going back to the first step, which is interesting. So we weren't sure. So I don't really need to have the memory. Right? I could just drop all the memory. I could just wait until the velocity gets to 0 again. I just wasn't sure if that we could do that. Knowing that, it actually gets easier, right? So, I don't know. TS_just is probably gone, but... Well, I'm not simulating it 3 times. I'm simulating each dimension separately. It will always be the first step. That's not the same as velocity equals 0. The first step, at the first step, the velocity is 0, though. Because you start out at velocity 0 for the first step. As in step number 0, like before you make the first step. You don't need to start the simulation over. I'm not starting it over for each axis. I'm just simulating each dimension separately. Does that make sense? So it's like we're advancing all the x's until it loops back, and then we're advancing all the y's until it loops back, and then all the z's. There can be other states where velocity is 0. Yeah. But we're finding the first one in each dimension, right? And then we're finding the least common multiple of all 3 dimensions. So if that's true, I really don't need the state history. Let me comment it out for now, just to make sure I understand this correctly. Then instead of checking this, I can just check that all of them are 0, like I had before. I had this bool all velocities 0. We assume it's true, and then we say if that is not equal to 0, then all velocity 0 is false. And then we say if all velocity is 0. That should give me the same answer without any memory, right? I screwed up somewhere. Well, yeah, we don't need to print that. That should give me the same answer without using any memory. Nope, it didn't. I messed something up. Ah, shoot. Oh, I see what you guys are saying. It could reach a velocity of 0 at some other point in space. Okay, so then I do need the memory, right? No, wait a minute. No, it's not. It's a different point in space. It could reach a velocity of 0, but at a different point in space. So I need to actually remember. I need to check to see if the positions are what the original positions were. That's why I had this thing actually. originally. Let's put that there. And so I can't just do this, can I? In fact, yeah, let's just drop all of this. Well, let's say all moons returned. So we'll compare the velocities and positions. So it's if that doesn't equal original moons. We need to know them which moon number it is. Crap. Or size t. M is 0. M is less than moon size plus m. Const auto moon is moons m. So that's original moons m. Dot velocity dot md. And position or position. There we go. Okay, so I get the correct numbers out now. So I don't need memory at all. So I'm going to drop the state history. I don't need that. Don't need any of this. And I don't need the report either. Or the encode dimension. Don't need any of that stuff. There we go. Never got why you size t over an int in C++ other than it can hold bigger values. It is, by definition, the type of size of... the size of operator always returns a value of type size t. So if you kind of are loose with the types and you don't mind mixing ints with size t's, then there's no real reason why to use size t. But if you're kind of strict on yourself and making sure the types always match and you do a type conversion if they don't, then you'll want to use size t. It's pretty much that simple. If you care about... if you're really picky about the types, then you'll use size t. If not, then just use int. Encode dimension is still used. Okay. Because I don't need that. There we go. So now it's very fast because I'm not actually looking through maps. So I really don't need to print this stuff anymore, do I? And then we'll say no, we don't need to print those anymore. We just need to record them. That's what I had this for this period here. Right, periods d. Dot md is step count. Actually, let's not use vector because that's ints. Let's just use this normal vector of size t's. And just use a pushback. All right, and then we're going to do find the least common multiple of the periods of each dimension. So const auto LCM is find least common multiple of periods and then print it out. So the moons return to their original positions and velocities after that many steps. LCM. So easy peasy. All we need to do is have the least common multiple. And so we'll make this a template, type name t, of const standard vector of type t of values, just because we can. And we'll have it return 0 for now. Why does that not work? But that's how you do a template function. Oh, do I need to do a t here? I always forget this syntax. I'll look it up. It's a C++ template function, or function template, really. Function templates. How does it look like? Oh, I need to have T in front. There we go. Return type. Thank you. I'll give you a point for that. You found it faster than I did. Finally cracked 2B. I found that was really hard. So the one I'm just doing now, I found the hardest, and I'm still working on it. The second hardest was 2B. Yeah, it took me a little bit over an hour to figure that out, and I still don't like my solution. I ended up brute forcing half of it. Yeah. Okay. Finding the least common multiple is basically getting all the prime factors out and then combining them, right? So let me think about this. The highest power of each prime number. So we kind of want to map from prime number to power, right? So we're going to want something like this. Type name T of a map. Actually, it can be an unordered map, sure. Unordered map from T to size T of prime factors of T value. Let's say just have it return nothing right now, just to get it to compile. So this will take, for everything here, we're going to end up with a vector of unordered maps, right? Prime factors. And then for for auto, value and values. Prime factors push back prime factors of value. And then I gotta go through them and I guess we'll take one and then go through a second one and add to it any that are not in the others. So we could start out with an empty one. Let's say prime factors for values. And this is prime factors for LCM. And then we'll say for const auto, prime factors in prime factors for values. And then we're gonna look through every prime number for auto prime in prime factors. Dot or arrow. Hold on. Unnamed. It's gonna be an unordered map. So then, yeah. So prime factors entry. Const auto prime is this one's first. Shoot. Yeah, const auto again, right? And then this all compile? No, it doesn't. Because why? Because I can't do that? Unordered map is not declared, that's why. How about now? This tells you how much I depend on IntelliSense. Like when the IntelliSense started to fail, it couldn't tell me the type of the thing, then I'm like got really nervous. Still doesn't like it. It says it's unnamed. It knows it down to here, but then it gets confused. It says it's unnamed, which is really weird. But if that's a vector of unordered maps, that's an unordered map. And then when you iterate on an ordered map, you get a pair. And the first is the prime number, and the second one is the, what do they call it? Power. Okay, and then we need to see is it already in here. If it's already in there, we just increase the power. Otherwise, well, okay, yeah. So it'll be in there. So if it's not, we need to add it. So prime factor for LCM equals prime factors for LCM prime. And then we want to say that that equals the maximum of that and power. Okay. Then the final computation is we go through this one and multiply them out. So T LCM is 0, and then 4 const auto. Prime factor in prime factors to LCM. Again, we'll get these ones here. It's LCM plus equals prime power of prime to power. Pow exists for integers, right? Pow. It does not. Oh well. Shouldn't it though? Why is it only for floating point? Well, we can just say for size. I need to give it a name. T factor is prime. For size T, I is 1, I is less than power, plus I. A factor times equals prime. And then LCM plus equals factor. All right, return LCM. Let's see if I got it right. Nope. Let's... Oh, because I didn't get the prime numbers. Okay, shoot. So to get the prime numbers, we just try to... we have to get... we have to know what... we need to generate prime numbers. Are C++ templates similar to Java generics? I'm not sure about Java generics or C# generics. It's more of like a pattern that the compiler uses to supply a function more than generics are more like functions that where the code can operate on many different types, and the type is itself a runtime parameter. At least that's how I understood what a generic was. For a C++ templates, it's more of like a recipe that you use to bake in a function. So if I use this with int and then I use it again with size t, I'll actually get 2 different functions. So there'll be 2 different copies of the code. Whereas with the usual generic, there's one copy of the code, but everywhere where you have the type parameter, there's runtime code to deal with the differences in the argument, the type argument. I'm running out of time, actually. I got less than 9 minutes to do this. And is this... How do you do prime factorization? That's... How do you find the prime... Let's look. How do you find the finding prime factors of a number? I believe what you do is you keep dividing by increasing prime numbers until you get it down to a prime number, or until you get it down to 1. So how do you find prime numbers? How do you find prime numbers? I think, don't you just build it by running itself? Actually, yeah, why can't I just try every number? So we can have like a static vector of t's. Actually, can I do that with a template? I think I can. Primes. We need to go until we get the value down to 1, right? So while value is greater than 1. Last you remember there isn't an algorithm for prime numbers? Well, we'll make one, right? So we'll end up with factors, right? Prime factors. We're going to return that. Beast down, I know. Beast left. Goodbye, Beast. The Beast is probably telling me it's about time for me to end my stream. Okay, while the value is greater than 1, we have to say it while either primes is empty, shouldn't we start... Yeah, we should have like a next prime number. Next prime is we can calculate it up here. We can have it 0. We can actually do it this way. While next prime, actually we can just say if next prime is greater than or equal to prime size, then we need to calculate the next prime number, right? The way we do that is we would take the last prime number, or 1, and then I'll just do a really bonehead way. You can skip the even numbers after 2, but I'll just add 1 to each one. I'll say t candidate depends on if primes is empty. Actually, I don't need all those parentheses. If it's empty, then I will try 2. Otherwise, we're going to try the last prime number plus 1. Primes length minus 1 plus 1. Okay, and then we're going to try to see if it's prime again by getting its prime factors, right? So const auto candidate factors equals prime factors of candidate. If... Oh, and we have to repeat this one, right? Yeah. We can save that. Actually, we can just have a while. Or do a do. Shoot. Infinite loop. If candidate factors empty, then it's prime. Else we need to go to the next candidate, so plus plus candidate. So it's prime here, so that means primes push back candidate. And then break. So then we have another prime number to check, right? So then we'll say if value mod primes next prime is 0, then it's a factor. So then we say prime factors push back primes next prime, and then value divide equals that prime number. And then we have to plus plus next prime outside the loop, right? Gotta go. See you, Rally Monkey. I hope this works. So this is actually calling itself to compute the prime numbers and caching them here so that we can use them to factor other things. I have no idea if this is going to work. What's wrong with this one? Primes... Why didn't this work? Oh, because 2 is not a t? No. Length is not a member of vector. Okay, it's not length, it's size. There we go. Well, thank you, Toulouse. Project is trying to solve Advent of Code Day 12, Part 2, and it's sort of a spoiler, but it involves prime factorization. Okay, why doesn't this work? Oh, because we're not pushing back. We need to add one. That means I don't want to advance one. It's else that, right? So we would say that prime factors that plus plus, right? All right, I have no idea if this is going to work. And it crashed. Let's go back to debug, and I'm just guessing that my prime number stuff is broken. I got only 2 minutes to debug it. Clock is ticking. Debug. Actually, it takes it a while to... Oh, I'm being raided by Simuleos. Hey, Simuleos. This is the end of my stream. I have been working on Advent of Code. I was on day 12, part 2, and it's a tough one. And I got the answer to the puzzle, but I kind of I didn't do it all in code. It's sort of a spoiler, so don't look if you want to solve this yourself, but the solution came down to you get 3 numbers and you need to find the least common multiple. And so I got the 3 numbers. I didn't have the code to do the least common multiple, so I just did it using an online tool and got the answer. And now I'm trying to do the correct to do what I wanted all along, just have my program do the complete solution. So in addition to getting those 3 numbers, compute the least common multiple, and which I forgot how to do. I had to look it up. To get the least common multiple of 3 numbers, you figure out what their prime factors are, and then you combine their prime factors and you multiply them. So that's what I'm trying to do, but there's a bug in my code somewhere, and I have like less than a minute before I have to go. Maybe I can stretch it a few minutes. So we're trying to find the prime factors of this number, 186,028. And it should say we have no prime numbers, so we're empty, so we need to try 2. And it should recurse. And then, oh, is it going to go infinite? Oh, it should say while value, it should say while value is greater than 1. There should be a check if the value, if the next prime equals itself. Right? Value is 2. Oh, no, it should be if it's 2, right. We need to make a special case for 2. But if we get to the last prime divided by 2, we can stop and say it's prime. I forgot about that. It was a secret stream. What was your secret stream about? I hope it went well. Okay, so for this, there's a special case, right? What was I doing here? Well, this is finding the next prime number. So when we're seeing if a value is prime, we should just have a shortcut if it's 2, shouldn't we? Yeah, we should say if value is less than 3. Well, 3 is also prime, right? So if value is less than 4, then return empty because it's prime. Otherwise, we can stop when the value is greater than half of the last prime number we know about. So while value is greater than... Actually, it's just this one, right? While value is less than... Well, there's this case where we don't know what the prime numbers are, right? No, we need that. We need that. I should break early. I should break early here. If value... Right. I should do it. This will end up putting something in the primes vector. So if value is greater than primes size minus 1 divided by 2, then we can break out of the loop. All right. It's tricky because the function calculates the prime numbers, caches them, and also uses those prime numbers to factor non-prime numbers. Okay, so this is that number, and it should say I need some prime numbers, so try 2, and that'll return early, so we know it's prime. So 2 is a prime. Then that doesn't, oh no, it did break. Oh, I got the math wrong, didn't I? We don't have enough prime numbers. Shoot. Let me think about this. We wanted to stop. It should always get the next prime number up, right? If it is greater than half of the last prime number, but is less than that prime number, that's what it is, right? If value is less than the prime number, and it's greater than half of the last prime number, then it has to be prime. All right. I really have to go, though. I'm just so close to finishing it. If this can just compute prime numbers, then we'll have least common multiple, and I'll get my answer, and I'll check it in. Okay, so it's going to re-enter. It's going to say it's 2. Okay, great. We have 2. And then it's going to divide by 2. Okay, 2 is a prime factor. Great. So it's going to try it again, right? And it's still divisible by 2. It's not divisible by 2 a third time, though. So we go to the next prime, and so we need another prime number. Our candidate is now 3. It's less than 4, so it's prime. So primes now has 2 and 3 in it. And it's not divisible by 3, so we go to the next. So then it's got to get another candidate. It's going to check if 4 is prime. I'm going to take out that breakpoint. The factors of 4 are... Okay, the powers are wrong. It's 2, 1. It should be 2, 2. It should be 2 to the power of 2. Did I get that wrong? I'll have to step through that the next time. Prime factors of 5. Oh, okay, now we crashed. Okay. Is prime numbers needed for least common multiple? Maybe not. Don't believe so. Yeah, I don't have time to figure out a different way. I'm literally out of time. I gotta go. I'm sorry, folks. I'll probably just finish this up when I get back and let you guys know the next time I stream what was the problem. But yeah, at least I made it through. Technically, what was it? According to my clock. Clock is still running, actually. I'm gonna stop at 2 hours 17 minutes, and then add to the clock when I work on it again, and then you know how much time it'll take me to actually get it running, and then I'll review that next time I stream. How about that? So this is what I did today. It was a lot less than I thought I'd do. I thought I'd at least get through 13, but 12-2 turned out to be really hard. But yeah, anyway, I really got to run, so let me find someone else I can raid. Let's see, who is streaming right now? Okay. I think we're going to raid CM Griffing, so don't know if you guys have noticed or not, but there's a nice overlay above my head that's showing chat, and the fine gentleman who wrote that is who we're going to raid. He's Mr. CM Griffing, and hope you enjoy his stream. He's working on that overlay and the monetization and marketing of it. So I'm going to go raid him right now. It was there on the list. Where did it go? There we go. Okay. Hold on, let me get this going. I don't like the new Twitch dashboard, the way it works. So slow for me to get used to new things. Okay. Hitting the button. And yeah, I should be back tomorrow. About 10 a.m. my time, so that's 1800 hours UTC. So hope to see you then. And in the meantime, enjoy CM Griffing and have a pleasant rest of your day. Bye. Bye.